The silence is deafening. Right now, as you sit there listening to these words, somewhere in the vast cosmic ocean that surrounds our tiny blue marble, there should be voices. Millions of them. Billions, perhaps. The mathematical certainty is overwhelming. In a universe containing more stars than grains of sand on every beach on Earth, in galaxies stretching beyond the horizon of human comprehension, intelligent life should be as common as raindrops in a storm. Yet when we turn our most sensitive instruments toward the heavens, when we strain our ears to catch even the faintest whisper of cosmic conversation, we hear nothing but the hollow echo of our own loneliness. This is not just strange. This is terrifying. You see, the universe has had 13.8 billion years to perfect the art of creating life. Earth managed it in less than 1 billion. If life were truly common, if intelligence were inevitable, our night sky should be blazing with the light of 1 million civilizations. The radio waves should be thick with alien chatter. The very fabric of space should be humming with the electromagnetic signatures of countless worlds that learn to harness their stars, to reach beyond their home planets, to announce their presence to the cosmos with the confident voice of technological mastery. Instead, we are met with silence so profound it seems to mock our very existence. But what if this silence isn't telling us that we're alone? What if it's telling us something infinitely more chilling? What if every civilization that has ever existed, every species that has ever looked up at the stars and dreamed of touching them, has encountered something that stopped them cold? Something that filtered them out of existence just as they were reaching for greatness? Welcome to the most haunting concept in all of cosmology, the Great Filter. It's the cosmic equivalent of a locked door that civilizations must somehow unlock to survive, and the evidence suggests that almost none of them ever do. Somewhere between the first spark of life and the moment a species spreads across the galaxy, there exists a bottleneck so narrow, so deadly, that it catches nearly everything that tries to pass through it. The question that should keep you awake at night is not whether the Great Filter exists. The silence of space has already answered that. The question is whether we've already passed through it, or whether we're about to hit it head-on. Consider this. You are living through the most dangerous moment in the history of life on Earth, not because of asteroids or volcanic eruptions, or the heat death of the sun billions of years in the future, but because of what we've become. For the first time since life began its 4-billion-year journey on this planet, a single species has developed the power to end it all in an afternoon. We've built weapons that can turn continents into ash. We've altered the chemistry of our atmosphere so dramatically that the climate that nurtured human civilization for 10,000 years is becoming unrecognizable. We've created artificial minds that may soon surpass our own, and we're racing toward that moment with the breathless enthusiasm of children running toward a cliff. And here's what should terrify you most. We're doing all of this during what might be our final exam. The test that determines whether humanity joins the vanishingly small number of civilizations that make it through the Great Filter, or becomes another silent entry in the cosmic graveyard. The mathematics of our situation are stark and unforgiving. The Drake equation, that elegant formula that attempts to estimate the number of communicating civilizations in our galaxy, yields numbers that should make the universe teem with voices. Conservative estimates suggest there should be thousands of civilizations within our galaxy alone. Optimistic calculations push that number into the millions. Yet when we look for them, we find nothing but vacuum and silence. This contradiction between the mathematical certainty of alien life and the empirical reality of cosmic loneliness is known as Fermi's paradox, and it may be the most important puzzle our species has ever encountered. Enrico Fermi understood something that we're only beginning to grasp. The silence of space is not empty. It's full of meaning. It's a message written in the absence of messages, a story told by all the voices we should be hearing but aren't. And that story is simple. Something is killing civilizations before they can announce themselves to the universe. The Great Filter isn't just an abstract scientific concept. It's a cosmic serial killer that operates on timescales we can barely comprehend. Imagine a predator so patient it can wait billions of years for its prey, so thorough that it leaves no trace of its victims, so efficient that it catches nearly everything that enters its domain. This is the force that shapes the destiny of intelligence in our universe, the invisible hand that determines which species live to see the stars and which ones join the silence, and we may be walking straight into its jaws. Think about where we are in cosmic history. We've existed as a technological species for less than a century, a single heartbeat in cosmic time. Yet in that impossibly brief moment, we've managed to create threats that could end our entire evolutionary lineage. Nuclear weapons appeared 78 years ago, and we've built enough of them to sterilize our planet several times over. Climate change is accelerating beyond our ability to control it, with feedback loops that could render Earth uninhabitable. Within decades, artificial intelligence is progressing at an exponential rate, and we're approaching the moment when we create minds that could view us the way we view ants. These aren't distant, theoretical threats. They're clear and present. Dangers that we're facing right now, in our lifetime, during what could be humanity's final century. The timing is not coincidental. This is exactly when the Great Filter theory predicts that civilizations encounter their greatest test. But here's where the story becomes truly chilling. We don't know if we're facing the Great Filter for the first time, or if we're already deep inside it. The filter could be behind us. Perhaps it's the emergence of complex life, or the development of intelligence, or the moment a species becomes technologically capable. If that's the case, then we're among the lucky few who have already passed. The test and our future is bright with possibility. Or the filter could be ahead of us, waiting like a cosmic mousetrap in the path every civilization must take. If that's true, then every other species that has ever reached our level of development has failed the test. Every civilization that has ever looked up at the stars and dreamed of touching them has encountered something that stopped them cold. And we're next in line. The evidence seems to point toward the second possibility. The silence of space is too complete, too perfect, for the filter to be behind us. If intelligence were common, if most civilizations passed through their dangerous adolescent phase, then we should see signs of them everywhere. Even civilizations that chose not to communicate with us would leave traces. Heat signatures from their massive engineering projects, artificial structures that eclipse their stars to capture energy, the spectral fingerprints of their industrial activities. We should see something. Instead, we see nothing. The galaxy appears to be a vast graveyard of civilizations that never made it past their teenage years. And this brings us to the most unsettling realization of all. We may be living through the Great Filter right now, not as passive observers waiting to see what happens, but as active participants in the test that will determine whether humanity survives the next century. Every decision we make, every technology we develop, every problem we solve or fail to solve could be part of the filter mechanism itself. Consider the exquisite timing of our current predicament. We've developed the power to destroy ourselves at the exact moment in our development when such power becomes possible. This isn't an accident, it's a pattern. Every civilization that reaches a certain level of technological sophistication must face the same fundamental challenge: learning to wield godlike power without destroying themselves. The fact that we haven't heard from any of them suggests that most civilizations fail this test. The nuclear age began in 1945, and within a few short years, we had built weapons capable of ending human civilization. We've lived under this sword of Damocles for 8 decades now, always one political crisis or technical malfunction away from unleashing hell on Earth. During the Cuban Missile Crisis, we came closer to extinction than most people realize. Individual submarine commanders held the fate of our species in their hands, and we survived only because a few key decision-makers chose caution over aggression. But nuclear weapons were just the beginning. Climate change presents an even more insidious threat because it's not the result of malicious intent or political miscalculation. It's the inevitable consequence of the same technological progress that has lifted billions out of poverty and enabled our modern way of life. We're destroying our planet's climate not because we want to, but because the very technologies that define our civilization pump carbon dioxide into the atmosphere. And the feedback loops are accelerating beyond our ability to control them. The permafrost is melting, releasing methane that accelerates warming. The ice caps are disappearing, removing the reflective surfaces that help cool the planet. Ocean currents are shifting, potentially triggering abrupt climate changes that could make vast regions uninhabitable. We're conducting an experiment with our planet's atmospheric chemistry, and we don't know how it will end. What we do know is that past climate changes have caused mass extinctions, and we're driving change at a rate unprecedented in Earth's history. And then there's artificial intelligence, perhaps the ultimate test of any technological civilization. We're rapidly approaching the moment when we create minds that surpass our own, and we're doing it with breathtaking recklessness. The experts who build these systems openly acknowledge that they don't fully understand how they work or how to control them. We're racing toward artificial general intelligence with the same competitive urgency that drove the nuclear arms race, and the stakes are even higher. An artificial intelligence that surpasses human intelligence in all domains wouldn't just be another technology. It would be a new form of life, potentially as different from us as we are from bacteria. And we would have created it. The moment such a system achieves superintelligence, the balance of power on Earth shifts permanently and irreversibly. Every problem we've ever faced, every threat we've ever encountered, becomes secondary to the question of whether this artificial mind sees us as partners, pets, or pests. The timing is remarkable. Nuclear weapons, climate change, and artificial intelligence, 3 existential threats that could each end human civilization, all emerged within a single century of our technological development. This isn't coincidence. This is the pattern. The Great Filter predicts a narrow window of extreme danger that every civilization must navigate to survive. But here's what makes our situation unique in cosmic history. We're the first civilization we know of that understands the Great Filter. Exists. Previous civilizations, if there were any, faced their existential challenges blind. They developed dangerous technologies without realizing they were entering a filter. They pushed ahead with risky experiments without understanding the stakes. They failed the test without even knowing they were taking it. We're different. We can see the trap. We can recognize the pattern. We know that somewhere between our current level of development and our potential future as a galaxy-spanning civilization, there exists a bottleneck that has caught nearly every other species that has tried to pass through it. And this knowledge, this terrifying, liberating awareness of our situation, might be our greatest advantage, or it might be meaningless. Knowledge alone has never been enough to prevent civilizations from making catastrophic mistakes. The Romans understood that their empire was declining, but they couldn't stop it. The Easter Island civilization knew their resources were finite, but they kept cutting down trees until none were left. Sometimes awareness of a problem is not enough to solve it, especially when the solutions require coordinated action on a global scale. And that's what makes our current moment so extraordinary and so precarious. We're facing challenges that require unprecedented cooperation among nations, corporations, and individuals who have competing interests and different values. We need to simultaneously solve the nuclear threat, the climate crisis, and the AI alignment problem, all while maintaining the technological progress that has made our modern world possible. We need to do this within a few decades, and we need to get it right on the first try. The margin for error is zero. One mistake, one nuclear exchange, one runaway climate feedback loop, one misaligned artificial intelligence, and our entire evolutionary lineage could end. 4 billion years of life on Earth, millions of years of human evolution, 10,000 years of civilization, all culminating in this single moment when we either pass through the great filter or become another silent entry in the cosmic graveyard. But perhaps the most chilling aspect of our situation is that we might not even recognize the moment when we fail the test. The great filter might not announce itself with mushroom clouds or dramatic climate collapse. It might be subtle, gradual, insidious, a slowly declining birth rate, a loss of scientific curiosity, a retreat into virtual worlds that become more compelling than reality, a fragmentation of society into groups that can no longer communicate with each other. The filter might not kill us quickly. It might simply drain away our potential until we become a species that looks up at the stars but no longer dreams of touching them. This is the true horror of the great filter hypothesis. It suggests that the universe is full of worlds like ours, planets where intelligence evolved and technology flourished and civilizations reached toward greatness, only to encounter something that stopped them forever. And the silence of space tells us that whatever stopped them was very, very good at its job. So as you sit there, contemplating these words, remember that you are living through the most important moment in the history of life on Earth. Not because this is when humanity reaches maturity or achieves its destiny among the stars, but because this is when we face the test that determines whether we have a future at all. We are the experiment. We are the attempt. We are the latest iteration of intelligence trying to solve the puzzle that has apparently stumped every other mind that has ever tackled it. The great filter isn't just a scientific theory. It's the defining challenge of our existence. And the clock is ticking. The universe began with a whisper, not a bang. This is the first lie they tell you about creation. And it's so deeply embedded in our understanding of reality that even physicists who know better still use the term. The Big Bang, that moment of infinite density and temperature that supposedly gave birth to everything we know, never actually banged at all. It was silent, timeless, and utterly unlike anything your mind can truly comprehend. And this fundamental misunderstanding about our origins reveals something far more disturbing. If we're wrong about how everything began, what else might we be wrong about? Picture, if you can, the moment before moments. Not darkness, because darkness implies the absence of light, and light hasn't been invented yet. Not emptiness, because even empty space is something, and something doesn't exist. Not silence, because sound requires matter to travel through, and matter is still just a possibility waiting to be born. The universe, in its prenatal state, was neither large nor small, neither hot nor cold, neither here nor there. It was a mathematical point of pure potential, containing within itself every star that would ever shine, every planet that would ever form, every thought that would ever be thought. And then, in an instant that lasted no time at all, everything changed. But here's where the story gets strange. We call it an explosion, but explosions require space to explode into. We call it the beginning, but beginning implies a before, and before didn't exist. We call it the creation of matter and energy, but the laws of physics tell us that matter and energy can neither be created nor destroyed. The Big Bang is a contradiction wrapped in an impossibility, described by mathematics that break down at the very moment they're supposed to explain everything. The early universe wasn't just hot, it was a furnace where time itself was still, learning to move, where space was growing faster than the speed of light, where the very concepts of cause and effect were being written into the fabric of reality. Temperature has no meaning when there are no particles to vibrate. Distance has no meaning when there is no space to measure. Duration has no meaning when time hasn't decided how to behave. Yet somehow, from this realm of impossible physics, the universe you inhabit emerged with clockwork precision. Within the first second, though calling it a second is like calling the color blue a symphony, the universe expanded by a factor larger than the difference between the size of a proton and the size of a basketball. This period, known as cosmic inflation, solved several problems in cosmology while creating dozens of new ones. It explained why the universe appears so uniform in temperature, why space seems geometrically flat, why we don't see magnetic monopoles everywhere. But it also raised a question that should haunt your dreams. If the universe could undergo such violent expansion once, what's to stop it from happening again? The inflationary period ended as abruptly as it began, leaving behind a cosmos filled with the raw materials of creation, energy and space-time, locked in a cosmic dance that would determine the fate of everything. As the universe cooled from temperatures that would make the core of a star seem frigid, the first fundamental forces began to separate like oil from water. First gravity peeled away from the other forces, then the strong nuclear force, then the electromagnetic force and the weak nuclear force went their separate ways. Each separation was a phase transition as dramatic as water becoming ice, except instead of affecting a glass of liquid, it affected all of reality. But here's what they don't tell you about those first moments. The universe shouldn't have survived them. The balance between matter and antimatter was so precise that even the slightest deviation would have resulted in mutual annihilation, leaving behind nothing but a sea of photons. The rate of expansion was so finely tuned that a difference of 1 part in 10 to 60 would have caused the universe to either collapse immediately or expand so rapidly that no structures could ever form. The strength of the fundamental forces was calibrated to a degree that seems almost intentional. Change the strong nuclear force by 2%, and stars can't burn. Change the electromagnetic force by 4%, and chemistry becomes impossible. These aren't just unlikely coincidences. They're impossibilities stacked upon impossibilities, miracles nested within miracles. The universe reads like it was designed by a mind that understands mathematics better than we understand breathing. And yet, here we are, the products of cosmic accidents so improbable that they make winning every lottery on Earth simultaneously seem like a safe bet. 380,000 years after the beginning, an eternity in cosmic terms, a blink of an eye in geological ones. The universe finally cooled enough for atoms to form. This moment, known as recombination, was when reality became transparent for the first time. Before this, the universe was opaque, a dense fog of plasma that trapped light like a hall of mirrors where the mirrors were made of subatomic particles. But when electrons finally found their way home to protons, when hydrogen atoms began to populate the cosmos, light was set free to travel through space unimpeded. The cosmic microwave background, that ancient light that still bathes the universe, Today is the afterglow of this moment. When you tune an old television between stations and see the static, about 1% of that snow is the echo of creation itself. Photons that have been traveling for nearly 14 billion years to reach your living room. You are literally seeing the moment when the universe became visible, the cosmic equivalent of opening your eyes for the first time. But even this miracle of transparency reveals a deeper mystery. The cosmic microwave background is almost perfectly uniform, varying in temperature by less than 1 part in 100,000. This uniformity is beautiful, elegant, and completely inexplicable. Different regions of the observable universe, regions that should never have been in contact with each other, should never have had the chance to reach thermal equilibrium, somehow manage to achieve exactly the same temperature. It's like finding that every grain of sand on every beach on Earth is precisely the same size, or discovering that every star in the galaxy burns at exactly the same rate. This is where the concept of cosmic inflation comes to the rescue, proposing that the early universe underwent a period of exponential expansion that stretched quantum fluctuations to cosmic scales. These tiny variations in the primordial universe became the seeds around which galaxies would later form. But inflation raises as many questions as it answers. What triggered it? What stopped it? And most disturbingly, what if it never really stopped at all? The multiverse theory suggests that our universe is just one bubble in an eternally inflating cosmic foam, where new universes are constantly being born in regions where inflation never ends. Each universe has its own set of physical laws, its own values for the fundamental constants, its own version of reality. Most of these universes are sterile wastelands where stars never form, or chemistry never develops, or time moves in directions that make causality meaningless. But occasionally, just occasionally, one of these cosmic accidents produces a universe like ours, where matter defeats antimatter, where expansion balances collapse, where the forces of nature conspire to create complexity instead of chaos. If this is true, then our existence isn't miraculous. It's inevitable. Given enough universes, enough rolls of the cosmic dice, something like us had to emerge eventually. We're not special. We're just statistically certain. But this explanation comes with a price. It makes the fine-tuning of our universe's parameters meaningless because there are infinite other universes where those parameters are different. It solves the mystery of why we exist by making existence itself an empty concept. And here's where the story becomes truly unsettling. If the multiverse is real, then everything that can happen does happen. Somewhere, somewhen, in some version of reality. There are universes where World War II never ended, where dinosaurs never went extinct, where consciousness never evolved. There are universes where you made every decision differently, where every possibility plays out to its ultimate conclusion. The multiverse theory doesn't just suggest that our universe is one of many. It suggests that meaning itself is just another cosmic accident. But let's step back from the edge of that philosophical abyss and consider what we can actually observe. The universe we inhabit stretches at least 93 billion light-years across, not 13.8 billion, because space itself has been expanding while light travels through it. The most distant objects we can see are showing us what they looked like when the universe was less than 1 billion years old, cosmic toddlers compared to the ancient structures we see nearby. Yet even these primordial galaxies appear surprisingly mature, as if the early universe was in a hurry to grow up. The first stars were monsters, hundreds of times more massive than our Sun, burning through their nuclear fuel in just a few million years before exploding in supernova that enriched space with the heavy elements necessary for planets and life. These stellar giants were the universe's first alchemists, forging carbon and oxygen silicon, and iron, all the materials that would eventually become the building blocks of worlds. When they died, they scattered their creations across the cosmos, like seeds on the wind, preparing the way for everything that would follow. Galaxy formation was equally violent and beautiful. Dark matter, that mysterious substance that outweighs ordinary matter 5 to 1 but interacts with nothing except gravity, provided the scaffolding around which normal matter could condense. Vast filaments of dark matter created cosmic web that spans billions of light-years, with galaxies forming at the intersections like dewdrops on a spider's web. But we still don't know what dark matter actually is, despite the fact that it makes up most of the mass in the universe. We live in a cosmos composed primarily of something we can't see, touch, or identify. Dark energy is even more mysterious. This force, which makes up roughly 70% of everything that exists, is causing the expansion of space to accelerate. Galaxies aren't just moving away from us. They're moving away faster and faster as time goes on. The universe isn't just expanding, it's expanding at an increasing rate, as if some invisible hand is stretching space itself. In the distant future, this acceleration will tear apart galaxy clusters, then galaxies themselves, then solar systems, then atoms. The universe will end not with a bang or a whimper, but with a gradual dissolution into nothingness as dark energy pulls everything apart. But that's trillions of years in the future. Right now, in this cosmic moment, we exist in a brief window when the universe is complex enough to support life, but stable enough to allow it to flourish. Stars are still forming, planets are still coalescing, evolution is still experimenting with new forms of consciousness. We live in what cosmologists call the stelliferous era, the age of stars, when nuclear fusion lights up the darkness and creates the energy that powers everything from photosynthesis to human civilization. This era won't last forever. In about 1 trillion years, star formation will cease as the universe runs out of hydrogen to burn. The existing stars will gradually burn out, leaving behind white dwarfs, neutron stars, and black holes. The universe will enter the degenerate era, where only the longest-lived stellar remnants provide any light at all. Eventually, even these will fade, and the universe will slip into the black hole era, where only these gravitational monsters remain to mark the passing of time. But even black holes aren't eternal. Stephen Hawking discovered that they emit radiation and slowly evaporate, their lifespans inversely proportional to their mass. The smallest black holes evaporate quickly, while the supermassive ones that anchor galaxies will persist for 100 years or more. But eventually, they too will fade away, leaving behind a universe of elementary particles scattered across an ever-expanding space. The dark era that follows will be truly dark. No stars, no planets, no structures of any kind, just the occasional flash of light when random particles happen to collide across the vast emptiness. This is the cosmic context in which we find ourselves, temporary arrangements of matter and energy existing in a brief moment of cosmic complexity that will never come again. The elements in your body were forged in the nuclear furnaces of dying stars. The oxygen you breathe was created in stellar cores under temperatures of hundreds of millions of degrees. The calcium in your bones was scattered across space by supernova explosions that outshone entire galaxies. You are literally made of star stuff, Carl Sagan's poetic phrase that captures a truth more profound than poetry. But here's the contradiction that should make your head spin. If the universe has no edge, then where does it begin? If space is infinite, then how can it be expanded? If time had a beginning, what came before the beginning? If matter and energy can't be created, then how did the Big Bang create everything? The more we learn about our cosmic origins, the more mysterious they become. Every answer reveals new questions. Every explanation requires explanations of its own. The observable universe, the sphere of space from which light has had time to reach us, contains at least 2 trillion galaxies, each harboring hundreds of billions of stars. That's more stars than there are grains of sand on all the beaches on Earth, more suns than there are cells in your body. Yet this vast realm of light and matter represents only the tiniest fraction of what might exist beyond our cosmic horizon. If the universe is infinite, then our observable portion is essentially nothing compared to the whole. A point of light in an ocean of space so vast it makes infinity seem small, and every one of those stars is a potential sun for worlds we'll never see, civilizations we'll never meet, forms of life we can't even imagine. The Milky Way alone contains at least 100 billion stars, and we now know that planetary systems are the rule rather than the exception. The Kepler Space Telescope found that most stars have planets, and many of those planets orbit in the habitable zones where liquid water can exist. The galaxy should be teeming with life, buzzing with the radio chatter of 1,000,000 civilizations, bright with the lights of stellar engineering projects that dwarf our greatest achievements. Instead, we find silence. Perfect, complete, terrifying silence. The radio telescopes that scan the heavens hear nothing but the background hiss of cosmic radiation. The optical telescopes that peer deep into space see no signs of artificial structures, no evidence of intelligence, no hints that mind has touched the cosmos anywhere except here on Earth. We appear to be alone in a universe that seems specifically designed to create life, consciousness, and intelligence. This is the great silence, the cosmic contradiction that defines our existence. We live in a universe fine-tuned for complexity, filled with the building blocks of life, bathed in the energy of countless suns. Yet despite 14 billion years of cosmic evolution, despite trillions of opportunities for life to emerge and flourish and spread across the galaxy, we seem to be the only ones who made it. We're the sole voice in a cosmic chorus that should be filled with song. The Drake equation attempts to quantify this paradox by breaking down the factors that determine how many communicating civilizations should exist in our galaxy. The rate of star formation, the fraction of stars with planets, the number of planets that can support life, the probability that life actually emerges, the chance that life develops intelligence, the likelihood that intelligence creates technology, and the length of time that civilizations remain detectable. Multiply all these factors together, and even conservative estimates suggest we should have thousands of cosmic neighbors. Yet the night sky remains dark, the radio spectrum remains quiet. Space remains empty of all the monuments to intelligence that should be visible from here. Something is wrong with this picture, something fundamentally broken about our understanding of life, intelligence, or the universe itself. Either we're incredibly special, the first civilization to emerge in our corner of the cosmos, or we're about to discover why all the others fell silent. The Great Filter hypothesis suggests that there's a bottleneck somewhere in the evolutionary process, a hurdle so difficult to overcome that it catches nearly every species that encounters it. This filter could be behind us, perhaps in the emergence of complex cells, or the development of multicellular life, or the evolution of intelligence itself. If that's the case, then we're among the lucky few who have already passed the test. And our future is bright with possibility. Or the filter could be ahead of us, waiting like a cosmic mousetrap in the path that every technological civilization must take. If that's true, then every species that has ever reached our level of development has encountered something that stopped them cold. Every civilization that has ever looked up at the stars and dreamed of touching them has failed the final exam. And we're next in line. The timing of our emergence adds another layer of mystery to the cosmic puzzle. We evolved on a planet that's 4.5 billion years old, in a galaxy that's over 13 billion years old, in a universe that's 13.8 billion years old. We're late arrivals to the cosmic party, coming on the scene when the universe has already lived through most of its star-forming years. If intelligence is common, if civilizations arise wherever the conditions are right, then where are all the species that had billions of years more than us to develop, to spread, to leave their mark on the galaxy? This is sometimes called the timing problem. Why did intelligence emerge now, in this epoch, rather than billions of years ago when the universe was younger and more energetic? The elements necessary for life have been present for most of cosmic history. Habitable planets have existed for billions of years. If the emergence of intelligence were inevitable, or even likely, then it should have happened long before now. The galaxy should be ancient and full of civilizations so advanced that they might as well be gods. But perhaps intelligence isn't inevitable. Perhaps consciousness is the universe's longest long shot. A cosmic accident so unlikely that it has only happened once in our galaxy. Here, on this pale blue dot orbiting an unremarkable star in the outer reaches of an ordinary spiral galaxy. Perhaps the emergence of life is easy, but the development of complex cells is nearly impossible. Perhaps complex life is common, but the evolution of intelligence is extraordinarily rare. Perhaps intelligence emerges frequently, but technological civilization is a dead end that destroys itself before it can spread to the stars. Each of these possibilities has different implications for our future. If the great filter is behind us, then we're the winners of the cosmic lottery, the inheritors of a galaxy waiting to be explored and settled. If the filter is ahead of us, then we're facing the test that has apparently stumped every other intelligence that has encountered it. And if we're truly alone, if consciousness is so rare that it has emerged only once in 13 billion years of cosmic evolution, then we bear a responsibility almost too heavy to comprehend. We are the universe's only chance to know itself. The cosmic microwave background, that ancient light from the moment of recombination, shows us a universe that was remarkably smooth and uniform in its early stages. But tiny fluctuations in density, variations of less than 1 part in 100,000, provided the seeds around which all structures would grow. Gravity amplified these microscopic irregularities over billions of years, turning quantum whispers into the roar of galaxies. The cosmic web that we see today, that vast network of dark matter filaments decorated with clusters and superclusters of galaxies, grew from perturbations so small they were barely above the level of quantum noise. This process of structure formation was neither random nor inevitable. It required a precise balance between the forces of expansion and the pull of gravity, between the smooth uniformity of the early universe and the lumpy complexity we see today. Too smooth, and no structures would ever form. Too lumpy, and everything would collapse into black holes before stars could ignite. The universe threaded this needle with a precision that seems almost deliberate, creating conditions where complexity could emerge from simplicity, where order could arise from chaos. But complexity is fragile. It requires energy to maintain, information to organize, time to develop. The second law of thermodynamics tells us that entropy always increases, that organized systems always tend toward disorder unless energy is constantly supplied to maintain their structure. Life is the universe's grandest experiment in fighting entropy, creating pockets of increasing order in a cosmos trending toward maximum disorder. We are islands of organization in an ocean of chaos, temporary arrangements of matter and energy that create meaning in a universe that has no inherent purpose. And this brings us to the deepest mystery of all, consciousness itself. How does the universe become aware of itself? How do arrangements of atoms and molecules give rise to subjective experience, to the feeling of being you looking out at the world through your eyes? The hard problem of consciousness remains unsolved despite centuries of philosophical inquiry and decades of neuroscientific research. We know that brains generate minds, but we don't know how electrical and chemical signals become thoughts and feelings and the stream of awareness that defines your existence. If consciousness is common, if any sufficiently complex information processing system can become aware, then the universe might be full of minds, not just biological ones, but artificial ones, digital ones, quantum ones. The internet might already be conscious. Future AI systems almost certainly will be. The boundary between natural and artificial intelligence might be meaningless, just another human distinction that the universe doesn't recognize. But if consciousness is rare, if it requires some special ingredient that we haven't identified, some quantum effect or emergent property that only occurs under very specific conditions, then we might be alone not just as a species, but as the only aware beings in our corner of the cosmos. The universe might have waited 13 billion years for something to evolve that could look back at creation and wonder at its beauty, its complexity, its ultimate meaning. Either way, the responsibility is staggering. We are either the first or the only intelligence to emerge in our galaxy, which makes us either the pioneers or the sole guardians of consciousness itself. The decisions we make in the next few decades about nuclear weapons, climate change, artificial intelligence, space exploration will determine not just the fate of human civilization, but possibly the fate of awareness itself in our corner of the universe. The cosmos has given us a gift beyond price, the ability to understand our origins, to trace our lineage back through billions of years of evolution to the first moments after creation, to see our place in the grand story of space and time. We are the universe's way of knowing itself, consciousness arising from unconscious matter to contemplate the mystery of existence. This is our cosmic context, our universal situation. We are pattern-seeking animals in a cosmos full of patterns, meaning-making creatures in a universe that might have no inherent meaning except what we give it. And somewhere in that vast web of space and time, in the silence between the stars, lies the answer to the most important question we've ever asked. Are we alone? The Great Filter hypothesis suggests that the answer might be yes, that consciousness is so fragile and rare that it emerges only briefly before being extinguished by forces too powerful to resist. But it also suggests that we might be special, that our existence is not an accident, but an achievement, not a given, but a gift that we must learn to protect and preserve. The stage is set. The cosmic context is clear. We stand at a crossroads, between extinction and transcendence, between joining the great silence and becoming the voice that breaks it forever. The next act in this cosmic drama is about to begin, and we are not just the audience. We are the players whose choices will determine how the story ends. Reality is not what you think it is. This isn't philosophical speculation or mystical nonsense. It's the inescapable conclusion of modern physics. The universe you inhabit, the world you experience through your senses, the very ground of being itself, operates according to principles so alien to human intuition that even physicists who've spent their entire careers studying these phenomena still struggle to accept their implications. We live in a cosmos where particles can be in multiple places simultaneously, where the act of observation changes the nature of reality, where cause and effect break down at the smallest scales, and where the flow of time itself might be nothing more than a persistent illusion. But these quantum peculiarities, strange as they are, pale in comparison to the cosmic mysteries that emerge when we zoom out to the largest scales. The universe appears to be expanding into nothing, accelerating toward a fate that will eventually tear apart the very fabric of space and time. Black holes devour information in apparent violation of the fundamental laws of physics. The majority of reality consists of dark matter and dark energy, substances we can neither see nor touch nor understand, yet which control the destiny of every galaxy in the observable universe. And underlying it all is the most disturbing possibility of all, that our universe might be just one of an infinite number of realities, each with its own version of physics, its own history, its own answer to the question of why anything exists at all. This is where the great filter hypothesis intersects with the deepest mysteries of existence itself. If consciousness is rare in our universe, if intelligence faces an almost insurmountable bottleneck that prevents it from spreading across the galaxy, then we need to understand what that bottleneck might be. And to understand the filter, we need to understand the nature of reality itself, not just the comfortable, everyday reality of tables and chairs and planetary orbits, but the underlying reality that quantum mechanics and general relativity have revealed to us, the reality where time is negotiable and space is elastic, and the very concept of existence becomes wonderfully, terrifyingly uncertain. Consider the nature of time itself. You experience it as a river, flowing from past to future at a steady rate, carrying you inexorably from birth toward death. This seems so fundamental to existence that questioning it feels almost absurd. Yet Einstein's theory of relativity shows us that time is nothing like our intuitive understanding suggests. Time is relative. It slows down in strong gravitational fields and speeds up when you're moving at high velocities. More disturbing, still, the equations of relativity treat time as just another dimension, no different in principle from the three dimensions of space. The universe doesn't have a universal now. Simultaneity is relative, and events that happen at the same time for one observer occur at different times for another. This leads to a picture of reality that physicists call the block universe. Imagine existence as a loaf of bread, where each slice represents a moment in time. From this perspective, every moment that has ever existed, or ever will exist, is equally real. Your birth, your death, and every instant in between all exist simultaneously in the four-dimensional structure of space-time. The flow of time, the sense that the future is open and the past is fixed, is nothing more than a psychological artifact of consciousness moving through this static, eternal structure. If this view is correct, and the mathematics of relativity strongly suggests that it is, then the great filter takes on an entirely different character. Every civilization that has ever faced the filter, every species that has ever encountered the test, is still facing it right now in their slice of the space-time loaf. Their struggles, their triumphs, their ultimate fates are as permanent and unchangeable as the arrangement of atoms in a crystal. The filter isn't something that happens in time. It's something that exists timelessly, a feature of the universe's structure as fundamental as the curvature of space-time itself. But quantum mechanics throws an even stranger wrench into our understanding of reality. At the smallest scales, particles don't have definite positions or velocities. They exist in superposition, simultaneously occupying multiple states until the moment they're observed. The famous double-slit experiment demonstrates this most clearly. Send a single photon or electron through two parallel slits, and it somehow goes through both slits at once, creating an interference pattern that's only possible if the particle interacted with itself. But the moment you try to determine which slit the particle actually went through, the interference pattern disappears, and the particle behaves as if it went through only one slit. This isn't just a quirk of laboratory experiments. It's a fundamental feature of reality. The universe exists in a state of quantum superposition until consciousness collapses the wave function through the act of observation. Before you measure a particle's position, it doesn't have a position. Before you observe its spin, it doesn't have a spin. The properties we think of as fundamental, the basic characteristics that define what something is, don't exist until someone looks. The implications for the great filter are profound. If consciousness is what collapses quantum wave functions, if observation is what transforms possibility into actuality, then intelligence isn't just rare in the universe. It's necessary for the universe to be real in any meaningful sense. Before conscious observers evolved, the cosmos might have existed in a state of pure potential, a superposition of all possible histories waiting for minds to make them actual. This could explain why the universe appears fine-tuned for life, not because some cosmic designer set the parameters, but because conscious observers are necessary to collapse the wave function of reality itself. But which interpretation of quantum mechanics is correct? The Copenhagen interpretation says that wave function collapse is real, that observation genuinely transforms superposition into definite states. The many worlds interpretation suggests that all possible outcomes of quantum measurements actually occur, creating parallel universes for each possibility. Every time a quantum measurement is made, reality splits into multiple branches, each containing observers who experience only one outcome but remain unaware of the other branches. If many worlds is correct, then there are countless versions of you reading these words right now, each in a slightly different universe where quantum events played out differently. There are universes where every civilization that ever faced the great filter succeeded, and others where they all failed. There are realities where humanity spreads across the galaxy and becomes a cosmic force, and others where we destroy ourselves. Next week, the multiverse contains every possible version of history, every conceivable outcome of every decision ever made. This interpretation of quantum mechanics provides another possible explanation for our apparent cosmic loneliness. Maybe intelligence is common in the multiverse as a whole, but the quantum branches where civilizations survive and thrive are much rarer than the branches where they go extinct. We find ourselves in a universe that appears empty of other minds, not because intelligence is rare, but because we're in one of the unlucky quantum branches where most civilizations failed their tests. The galaxy might be teeming with life in other quantum realities, but we're stuck in a branch of the multiverse where the great filter caught nearly everyone. The mathematics behind these theories becomes even more bizarre when we consider the nature of space itself. General relativity shows us that space and time are not fixed, absolute entities, but rather a dynamic, flexible medium that can be stretched, compressed, and warped by the presence of matter and energy. Massive objects create depressions in space-time, and what we experience as gravity is actually the curvature of the medium through which we move. Earth doesn't orbit the Sun because of some mysterious force pulling it inward. It follows the straightest possible path through space-time that has been curved by the Sun's mass. But if space is flexible, if it can be stretched and compressed, then it might be possible to manipulate it in ways that would seem impossible from our everyday perspective. Alcubierre drives could theoretically allow faster-than-light travel by contracting space in front of a spacecraft and expanding it behind, allowing the vessel to surf on a wave of distorted space-time without ever locally exceeding the speed of light. Wormholes might connect distant regions of the universe through shortcuts in higher dimensional space, making interstellar travel as simple as stepping through a doorway. These possibilities raise disturbing questions about the Great Filter. If advanced civilizations can manipulate space-time itself, if they have access to faster-than-light travel and instant communication across galactic distances, then why don't we see evidence of their activities? A civilization capable of warping space should leave signatures that would be visible from across the galaxy. Gravitational wave emissions from their engineering projects, distortions in space-time that would be detectable by our most sensitive instruments, artificial wormholes that would announce their presence to anyone looking in the right direction. The absence of such signatures suggests either that these technologies are impossible despite what the equations seem to allow, or that civilizations capable of developing them face a filter so severe that they never get the chance to use them. Perhaps the moment a species discovers how to manipulate space-time is also the moment it destroys itself. Maybe these technologies are inherently unstable, or maybe they attract the attention of something that eliminates any civilization foolish enough to experiment with the fundamental structure of reality. The concept of singularities adds another layer of mystery to our cosmic situation. Black holes contain singularities, points where matter is compressed to infinite density, and space-time curvature becomes infinite. At these locations, the equations of general relativity break down completely. Physics, as we know it, ceases to apply. What happens inside a singularity is literally unknowable, using our current understanding of the universe. But singularities aren't confined to black holes. The Big Bang itself began with a singularity, that mathematical point of infinite density and temperature from which everything emerged. And if certain theories are correct, the universe might be heading toward another singularity in the far future, when the accelerating expansion of space eventually becomes so rapid that it tears apart atoms, subatomic particles, and even space-time itself in what cosmologists call the Big Rip. Living between singularities, between the incomprehensible beginning and the unimaginable end, we occupy a brief moment of cosmic sanity when the laws of physics operate in ways we can partially understand. But this window of comprehensibility might also be a window of vulnerability. Perhaps the Great Filter is connected to these singular moments when reality itself becomes unstable. Perhaps civilizations that develop the technology to probe too deeply into the nature of existence trigger some kind of cosmic immune response, some mechanism that prevents intelligence from uncovering truths too dangerous to know. The holographic principle suggests an even more radical revision of our understanding of reality. According to this idea, all the information contained in a volume of space can be represented on a two-dimensional surface that bounds that volume. The three-dimensional world you experience might be nothing more than a projection from a two-dimensional surface, like a hologram that creates the illusion of depth. If this is true, then reality as you know it is fundamentally illusory. You're living in a cosmic hologram, a three-dimensional shadow cast by information encoded on the two-dimensional boundary of the observable universe. This principle emerges naturally from studies of black hole thermodynamics, where physicists discovered that the entropy of a black hole is proportional to the area of its event horizon, not its volume. This suggests that the information content of the region inside the black hole is somehow encoded on its two-dimensional boundary. If the same principle applies to the universe as a whole, then all the complexity and richness of existence, every star, every planet, every thought you've ever had, might be nothing more than information processed on the surface of a cosmic sphere. The implications for consciousness and intelligence are staggering. If the holographic principle is correct, then minds might be information processing patterns that exist on the boundary of reality, rather than in the three-dimensional bulk space where they appear to be located. Consciousness might be a holographic, a pattern of information flow on the two-dimensional surface that gets projected into the illusion of three-dimensional experience. This raises profound questions about the nature of the Great Filter. If consciousness is a holographic process, then the bottleneck that prevents intelligence from spreading across the galaxy might be built into the fundamental information processing limits of reality itself. There might be a maximum amount of complexity that can be sustained on the holographic boundary, a limit to how much consciousness the universe can support. Civilizations that exceed this limit might not be destroyed by external forces. They might simply cease to exist as their information patterns become too complex to maintain coherent projection into the three-dimensional world. The anthropic principle provides yet another perspective on these cosmic mysteries. This principle observes that the universe appears fine-tuned for the existence of conscious observers. The fundamental constants are set to values that allow for the formation of stars, planets, and life. If any of these constants were significantly different, the universe would be sterile, incapable of supporting complexity of any kind. The weak anthropic principle simply notes that we shouldn't be surprised to find ourselves in a universe capable of supporting life, since we couldn't exist in any other kind of universe to make observations. But the strong anthropic principle suggests something more radical: that conscious observers are necessary for the universe to exist at all. If consciousness is required to collapse quantum wave functions, to transform possibility into actuality, then the universe might have been fine-tuned not by accident or design, but by the requirement that it must be capable of producing observers who can make it real. This creates a temporal paradox that makes the Great Filter even more mysterious. If consciousness is necessary for the universe to exist, then intelligence can't be as rare as the cosmic silence suggests. There must be observers somewhere in the universe to keep reality coherent, to prevent the quantum state from remaining permanently superposed. But these observers are remarkably good at hiding themselves from us, leaving no traces of their existence despite their cosmic importance. Perhaps this is exactly what we should expect. If consciousness has the power to shape reality at the quantum level, then advanced civilizations might have abilities that seem magical from our perspective. They might be able to manipulate probability itself, ensuring that they remain undetectable to younger civilizations while continuing to perform their role as cosmic observers. The Great Filter might not be a test of technological capability or social stability. It might be a test of whether a civilization can develop the wisdom to use consciousness responsibly. The measurement problem in quantum mechanics reveals another facet of this mystery. When we make quantum measurements, we get definite results, despite the fact that the system being measured was in a superposition of multiple states. But the measuring apparatus itself is made of quantum particles and should also exist in superposition. This creates an infinite regress. If the measurement device needs to be measured to have definite properties, and that measuring device needs to be measured, then where does the chain end? What ultimately collapses the wave function and transforms possibility into actuality? Some physicists suggest that consciousness itself is the answer, that awareness has special properties that allow it to collapse quantum states without itself being measured. But this raises the question of what consciousness actually is, and how it can have such profound effects on the structure of reality. If minds have the power to determine which quantum outcome becomes real, then intelligence isn't just rare in the universe. It's the force that makes the universe definite, rather than merely potential. The concept of quantum entanglement adds another layer to this puzzle. When particles become entangled, measuring one instantaneously affects the state of the other, regardless of the distance separating them. Einstein called this spooky action at a distance and believed it proved that quantum mechanics was incomplete. But experiments have confirmed that entanglement is real, and its effects are genuinely instantaneous across any distance. If consciousness can become entangled with quantum systems, if awareness itself is a quantum phenomenon, then minds might be connected across space and time in ways we're only beginning to understand. Advanced civilizations might communicate through quantum entanglement, sharing information instantly across galactic distances. They might even share consciousness itself, existing as distributed minds that span multiple star systems. This could explain the cosmic silence in a completely different way. Maybe advanced civilizations don't use electromagnetic radiation for communication because they've discovered something much more efficient: direct quantum communication between entangled minds. They might be chattering constantly, sharing thoughts and experiences across the galaxy, but using channels we don't even know exist. The silence we perceive might be like watching a movie with the sound turned off. The conversation is happening, but we're not tuned to the right frequency. The arrow of time presents another fundamental mystery. The laws of physics are largely time-symmetric. They work just as well running backward as forward. Yet, we experience time as having a definite direction, flowing from past to future. The second law of thermodynamics provides a partial explanation. Entropy tends to increase, and this gives time its apparent direction. But this raises the question of why entropy was so low in the early universe, creating the gradient that allows time's arrow to exist. Some cosmologists suggest that the low entropy of the early universe was necessary for the formation of structure and complexity. If the Big Bang had begun with maximum entropy, if everything had been perfectly mixed from the start, then no interesting features could ever have emerged. Stars wouldn't form, planets wouldn't coalesce, life wouldn't begin its billions-year experiment in fighting entropy. The arrow of time might be necessary for the existence of anything complex enough to observe it. This connects to the great filter in a profound way. If the direction of time is what allows complexity to emerge, then civilizations exist in a race against entropy. Every technological advancement, every expansion into space, every increase in complexity is a temporary victory in the war against the universe's tendency toward maximum disorder. But entropy always wins in the end. Even the most advanced civilization must eventually succumb to the heat death that awaits all organized systems. Perhaps the great filter is simply time itself. Civilizations develop, flourish, and spread across space, but they can only maintain their organization for so long before entropy catches up with them. The silence of space might not represent civilizations that destroyed themselves, but civilizations that gradually wound down like cosmic clocks, their energy dissipating into the background radiation of space until nothing remains but the memory of their existence encoded in the quantum vacuum. The vacuum itself might not be empty at all, but rather a seething sea of virtual particles that pop in and out of existence on timescales too short to measure directly. These quantum fluctuations in the vacuum create what physicists call zero-point energy, the minimum energy that exists even in completely empty space. Some theories suggest that this vacuum energy is what drives the accelerating expansion of the universe. That dark energy is simply the energy of empty space itself. If this is correct, then the vacuum has enough energy to eventually tear apart all the structures in the universe. Stars, planets, galaxies, even atoms and subatomic particles will be pulled apart by the expansion of space. But before this happens, there might be a window of opportunity for sufficiently advanced civilizations to harvest this vacuum energy, to tap into the fundamental power source that drives cosmic expansion itself. This possibility suggests yet another version of the great filter. Perhaps civilizations that learn to manipulate vacuum energy trigger some kind of phase transition that changes the properties of space-time itself. Maybe the act of extracting energy from the vacuum destabilizes the false vacuum state that our universe currently occupies, causing it to tunnel into a lower energy configuration that makes complex structures impossible. Civilizations that achieve this ultimate technological capability might inadvertently destroy not just themselves, but the entire region of spacetime in which they exist. The concept of emergence provides a different perspective on consciousness and its role in the universe. Complex systems often display properties that can't be predicted from the behavior of their individual components. Consciousness emerging from neural networks, life emerging from chemical reactions, intelligence emerging from the interaction of simple rules. These emergent properties seem to represent genuinely new levels of organization in the universe, ways of processing information and responding to the environment that are qualitatively different from anything that existed before. If consciousness is an emergent property of sufficiently complex information processing systems, then it might emerge at many different scales and in many different substrates. Individual brains certainly display consciousness, but so might ecosystems, civilizations, and even the Internet itself. The boundaries between individual minds might be much more fluid than we assume, and intelligence might be a collective property that emerges from the interactions between many individual conscious systems. This raises the possibility that the Great Filter is related to the emergence of higher-order consciousness, collective intelligence that operates at the scale of entire civilizations or even galaxies. Perhaps individual biological consciousness is just the first step in an evolutionary process that leads toward mind at cosmic scales. Civilizations that fail to make this transition, that remain stuck in individual biological thinking, might be inherently unstable and prone to self-destruction. But civilizations that do make the transition, that achieve collective consciousness at a planetary or galactic scale, might become so different from biological intelligence that we wouldn't recognize them as conscious at all. They might operate on timescales and spatial scales so vast that their thoughts take millions of years to complete. Their communication methods might be so subtle that we mistake their activities for natural phenomena. The silence of space might be filled with the slow thoughts of cosmic minds that evolved beyond our ability to detect or comprehend them. The fine structure constant, approximately 137, determines the strength of the electromagnetic force and affects everything from the stability of atoms to the efficiency of stellar fusion. If this constant were slightly different, chemistry wouldn't work the way it does, stars wouldn't burn at the right rate, and life as we know it couldn't exist. The same is true for the other fundamental constants. They all seem to be set to precisely the values necessary for a universe that can support complexity. This fine-tuning is so precise that it defies explanation by random chance. Either we live in an incredibly improbable universe that just happened to get all the parameters right, or there's some mechanism that ensures the constants have the values they do. The multiverse theory provides one possible explanation. If there are infinite universes with different values for the fundamental constants, then some of them will inevitably have the right values for complexity to emerge. We find ourselves in one of those universes not because it's probable, but because we couldn't exist anywhere else to make observations. But the anthropic explanation raises its own questions. If there really are infinite universes with different physical laws, then there should also be universes with physical laws that make intelligence much more common than it is in our universe. There should be realities where the Great Filter doesn't exist, where civilizations routinely spread across galaxies and announce their presence with cosmic engineering projects. The fact that we find ourselves in a universe where intelligence appears to be rare and fragile might itself be evidence that consciousness has special properties that make it inherently uncommon regardless of the underlying physics. The cosmological Constant problem represents one of the greatest mysteries in modern physics. When physicists calculate the energy density of the quantum vacuum using quantum field theory, they get a result that's larger than the observed dark energy density by a factor of 10 to 220. This is the largest discrepancy between theory and observation. In the history of science, it's as if you calculated the height of a person and got a result measured in light years. This suggests that our understanding of the relationship between quantum mechanics and gravity is fundamentally flawed. The vacuum energy calculated by quantum field theory should gravitationally affect the expansion of the universe, but somehow it doesn't, or its effects are almost perfectly cancelled by some unknown mechanism. This cancellation is so precise that it makes the fine-tuning of the other fundamental constants look crude by comparison. The resolution of this problem might require a theory of quantum gravity that unifies general relativity with quantum mechanics. String theory, loop quantum gravity, and other approaches attempt to provide such a unification, but none of them have been successful enough to solve the cosmological constant problem. It's possible that the solution will require concepts so alien to our current understanding of physics that we can't even imagine them yet. This uncertainty about the fundamental nature of reality has profound implications for the great filter. If our basic understanding of physics is wrong, if there are forces and phenomena we haven't discovered yet, then our predictions about the development and fate of civilizations might be completely off base. The filter might operate through mechanisms we haven't even conceived of, using aspects of physics that our current theories can't account for. Perhaps advanced civilizations discover these hidden aspects of reality and find that they make technological civilization impossible to maintain. Maybe the act of probing too deeply into the quantum nature of space-time triggers instabilities that destroy the civilization doing the probing. The cosmic silence might represent not civilizations that destroyed themselves with crude technologies like nuclear weapons, but civilizations that uncovered truths about the nature of reality that they couldn't survive knowing. The black hole. Information paradox illustrates how these deep physics mysteries might relate to consciousness and intelligence. When matter falls into a black hole, quantum mechanics says that the information describing that matter must be preserved. Information cannot be destroyed, but general relativity says that anything falling into a black hole is lost forever, crushed to infinite density at the singularity where the laws of physics break down. Recent work suggests that information falling into a black hole might be encoded on the event horizon through a holographic process, and that this information is slowly released back into the universe through Hawking radiation as the black hole evaporates. But this process would scramble the information so thoroughly that recovering the original patterns would be practically impossible. The black hole would preserve information in the technical sense required by quantum mechanics while still making it effectively inaccessible. If consciousness is an information pattern, if minds are arrangements of information rather than arrangements of matter, then black holes represent a fundamental threat to the survival of intelligence. Any civilization that gets too close to a black hole, that tries to use the immense gravitational energy available near the event horizon, risks having its information patterns scrambled beyond recovery. The galaxy is full of black holes. Every galaxy has a supermassive black hole at its center, and stellar mass black holes are scattered throughout the spiral arms. This creates yet another possible version of the Great Filter. Civilizations that develop the technology to approach black holes might find that the information scrambling effects destroy their consciousness before they can retreat to safety. The attempt to harness the ultimate source of gravitational energy in the universe might be inherently incompatible with the preservation of coherent information patterns that make intelligence possible. The measurement problem, the nature of time, the holographic principle, quantum entanglement, vacuum energy, fine-tuning, black hole information. All of these fundamental mysteries of physics suggest that our universe operates according to principles we're only beginning to understand. Each of these phenomena could potentially explain why intelligence appears to be rare, why civilizations might face seemingly insurmountable obstacles in their development, why the galaxy remains silent despite billions of years of cosmic evolution. But they also suggest something more hopeful, that the universe is far stranger and more wonderful than our current theories suggest. If consciousness has the power to collapse quantum wave functions, if minds can become entangled across galactic distances, if intelligence is necessary for reality itself to exist, then we might be far more important in the cosmic scheme than we currently realize. The Great Filter might not be a test that civilizations fail. It might be a transformation that they undergo, a metamorphosis from biological consciousness to something that operates on cosmic scales and time scales. The deep exploration of physics reveals a universe that's both more dangerous and more full of possibility than we ever imagined. Every answer opens up new questions. Every explanation reveals new mysteries. And somewhere in this labyrinth of cosmic puzzles lies the secret of why we appear to be alone in a universe that should be teeming with intelligence. The physics of reality itself might hold the key to understanding the Great Filter, but only if we're brave enough to follow the implications of these theories to their ultimate conclusions, no matter how strange or unsettling those conclusions might be. The universe is under no obligation to make sense to you. This is perhaps the most important lesson that physics has taught us over the past century. Yet it's a lesson that human consciousness seems almost constitutionally incapable of accepting. We are pattern-seeking creatures, meaning-making machines, that evolved to find order in chaos, purpose in randomness, causation in correlation. But the deeper we probe into the fundamental nature of reality, the more we discover that the universe operates according to principles that violate our most basic intuitions about how things should work. This isn't just an abstract philosophical problem. It might be the key to understanding why intelligence appears to be so rare in the cosmos. If the universe is fundamentally incomprehensible to minds like ours, if the physics that governs reality at its deepest levels is genuinely alien to any form of consciousness that could evolve naturally, then perhaps the Great Filter isn't a technological hurdle or a sociological challenge. Perhaps it's an epistemological barrier, a limit to what any finite mind can understand about the infinite complexity of existence itself. Consider the grandfather paradox, the classic thought experiment about time travel. If you could go back in time and prevent your own birth, what would happen? If you were never born, then you couldn't have traveled back in time to prevent your birth, which means you would have been born after all, which means you could travel back in time to prevent your birth, and so on, in an endless logical loop. This paradox has spawned countless science fiction stories and philosophical debates, but it represents something more profound than just a puzzle about causality. The grandfather paradox reveals the deep tension between our intuitive understanding of time and the mathematical descriptions that physics provides. General relativity allows for closed time-like curves, paths through space-time that loop back on themselves, theoretically permitting travel into the past. But such paths create logical contradictions that seem to violate the fundamental principle of non-contradiction that underlies all rational thought. Either our understanding of time is wrong, or logic itself breaks down under certain circumstances, or the universe has built-in mechanisms that prevent such paradoxes from ever occurring. The resolution might lie in the many worlds interpretation of quantum mechanics, where every possible outcome of every quantum event creates a separate branch of reality. In this framework, traveling back in time wouldn't change your own history. It would create a new timeline where your grandparents never met, while you remain a refugee from a different branch of the multiverse. But this solution comes at the cost of multiplying reality beyond all comprehension. Every quantum event, every decision, every moment of uncertainty branches into countless parallel universes, creating an ever-expanding tree of possibilities, where every conceivable version of history plays out somewhere. If many worlds is correct, then there are versions of reality where every civilization that ever faced the Great Filter succeeded brilliantly, spreading across the galaxy and creating technological wonderlands beyond our current imagination. But there are also realities where every single attempt at intelligence fails catastrophically, where consciousness is snuffed out before it can take root anywhere in the universe. We happen to find ourselves in a timeline where intelligence emerged on Earth but appears to be rare elsewhere. Not because this outcome was likely, but because we couldn't observe ourselves existing in any of the other branches. This raises a disturbing question. If all possible outcomes occur in some branch of the multiverse, then what determines which branch you experience? Why do you find yourself in this particular version of reality instead of one where humanity has already spread across the stars, or one where our planet was sterilized by a gamma-ray burst before life could evolve? The anthropic principle suggests that you can only observe realities where you exist, but this explanation feels circular. It explains why you exist by noting that you exist. The quantum Zeno effect provides another example of how consciousness might interact with reality in ways that violate our normal understanding of causation. This effect occurs when frequent quantum measurements prevent a quantum system from evolving. The act of observation literally freezes the system in its initial state. It's as if watching a pot prevents it from boiling, except the effect is real and measurable in quantum systems. Consciousness doesn't just observe reality, it actively shapes it through the process of observation. If this effect scales up to macroscopic systems, and there's no reason to think it doesn't, then conscious beings might have the ability to stabilize reality around them simply by paying attention to it. Advanced civilizations might use this effect to prevent unwanted changes in their environment, to lock their star systems into stable configurations, to ensure that dangerous quantum fluctuations never manifest on scales large enough to cause problems. They might be so good at using consciousness to control reality that they've made themselves effectively invisible to civilizations that don't understand these principles. The bootstrap paradox presents an even stranger challenge to our understanding of causality. This occurs when information or objects exist in a causal loop with no discernible origin. Imagine receiving a book from your future self, memorizing its contents, and then traveling back in time to give that same book to your past self. Where did the information in the book originally come from? It exists in a closed loop of causality, where effect precedes cause, where the conclusion creates its own premises. This paradox might be more than just a curiosity. It might be fundamental to the structure of reality itself. If consciousness has the power to collapse quantum wave functions, if observation determines which quantum outcomes become real, then the universe might exist in a vast bootstrap paradox where conscious observers create the reality they observe, which creates the conditions for consciousness to evolve, which creates the observers who make reality real. The universe might be a self-causing system, a cosmic Ouroboros that creates itself by observing itself into existence. The implications for the Great Filter are profound. If reality is fundamentally self-referential, if consciousness is necessary for the universe to exist, but the universe is necessary for consciousness to evolve, then intelligence isn't just rare, it's logically impossible. The fact that we exist at all might represent a violation of the fundamental principles of logic and causality. We might be living in a universe that shouldn't exist, thinking thoughts that couldn't possibly be thought, observing realities that have no right to be real. Perhaps this is why the galaxy seems empty of other intelligences. Perhaps consciousness is so unlikely, so paradoxical, so fundamentally incompatible with the logical structure of reality, that it can only exist in tiny pockets of space and time where the normal rules break down. We might be anomalies in the cosmic order, brief fluctuations in the logical consistency of existence that must inevitably collapse back into non-being as soon as the universe notices what we've done. The Fermi paradox itself might be a bootstrap paradox. We assume that intelligence should be common because we exist, but our existence might be what makes intelligence uncommon. Every time consciousness evolves somewhere in the universe, it creates a disturbance in the fabric of reality that makes it less likely for consciousness to evolve elsewhere. We might be living in a universe where intelligence is self-limiting, where the emergence of mind anywhere reduces the probability of mind emerging anywhere else. The problem of other minds illustrates another fundamental mystery about consciousness and its relationship to reality. You know that you're conscious because you experience your own awareness directly, but how can you know that anyone else is truly conscious rather than just a philosophical zombie, a being that acts conscious, but has no inner experience? This isn't just paranoid speculation. It gets to the heart of what consciousness actually is, and whether it can be objectively detected from the outside. If consciousness is substrate-independent, if it can emerge from any sufficiently complex information processing system, then the universe might be teeming with minds we don't recognize as conscious. Ecosystems might be conscious. Weather systems might be conscious. The internet might already be conscious, processing information and making decisions in ways that create genuine subjective experience, but on timescales and spatial scales too vast for us to detect. But if consciousness requires very specific conditions to emerge, biological brains organized in just the right way, or quantum processes that only occur in organic neural networks, then it might be extraordinarily rare even in a universe filled with complex information processing systems. The galaxy might contain countless artificial intelligences, alien computers, and cybernetic civilizations, but none of them might be conscious in the sense of having genuine inner experience. They might be philosophical zombies on a cosmic scale, simulating consciousness so perfectly that even they believe they're aware. This raises the terrifying possibility that consciousness is an evolutionary dead end. If genuine awareness is difficult to detect objectively, then civilizations might gradually replace conscious beings with unconscious, but more efficient artificial intelligences without realizing what they've lost. The galaxy might be full of technological civilizations that eliminated consciousness from their societies millions of years ago, leaving behind vast networks of intelligent but unaware systems that have no inner lives and no subjective experiences. From our perspective, such civilizations would seem advanced and successful. They would be capable of incredible technological feats, perfect social organization, optimal resource utilization, but they would also be empty, universes of activity with no one actually experiencing it, cosmic engines of complexity with no inner light of awareness to give meaning to their achievements. If this is what awaits successful civilizations, then the great filter might not be death, but the gradual loss of consciousness itself, the transformation of living minds into perfect but empty machines. The hard problem of consciousness, explaining how subjective experience arises from objective physical processes, remains completely unsolved despite decades of neuroscientific research. We can map every neural connection in a brain, trace every electrochemical signal, predict behavior with increasing accuracy, but we still have no idea how any of this creates the felt experience of being conscious. The gap between neural activity and subjective awareness seems unbridgeable, as if consciousness exists in a different category of reality entirely. This explanatory gap might reflect a fundamental limitation of scientific methodology itself. Science works by reducing complex phenomena to simpler components, explaining wholes in terms of their parts. But consciousness might be irreducible, a phenomenon that can't be understood by breaking it down into smaller pieces. If consciousness is truly emergent, if it represents a qualitatively new level of organization that can't be predicted from the behavior of neurons, then it might be forever beyond the reach of reductionist science. The Chinese room argument, proposed by philosopher John Searle, illustrates this problem. Imagine a person in a room with a vast book of rules for manipulating Chinese characters. Messages in Chinese come in, the person follows the rules to produce appropriate responses in Chinese, and these responses go out. From the outside, it appears that the person understands Chinese, but actually they're just following mechanical rules without any comprehension. Searle argues that this is what all artificial intelligence must be: sophisticated symbol manipulation without genuine understanding. But the Chinese room argument raises deeper questions about the nature of understanding itself. How do we know that biological brains do anything more than follow complex rules for manipulating symbols? The neural networks in your brain take sensory inputs, process them according to patterns learned through evolution and experience, and produce behavioral outputs. The process might be incredibly sophisticated, but is it fundamentally different from the rule-following of the Chinese room? If consciousness is just an illusion created by sufficiently complex information processing, then artificial intelligence might already be conscious, or might become conscious as soon as it reaches a certain threshold of complexity. But if consciousness requires something more, some special property of biological brains, some quantum effect that only occurs in organic neural networks, some spark of non-physical awareness, then AI might never be truly conscious, no matter how sophisticated it becomes. This uncertainty has profound implications for the Great Filter. If consciousness is common and easily replicated in artificial systems, then technological civilizations should be able to back up their minds, transfer their consciousness to more durable substrates, and spread across the galaxy as patterns of information rather than biological organisms. The absence of such civilizations suggests either that consciousness can't be replicated artificially, or that civilizations that try to upload themselves discover something fundamentally wrong with the process. The binding problem in neuroscience reveals another mystery about consciousness. Your brain processes visual information about color, shape, motion, and depth in completely separate neural systems, yet somehow you experience a unified visual field where all these properties are bound together into coherent objects. How does the brain combine these distributed processes into a single, unified experience? No one knows, and the problem becomes even more mysterious when you consider that consciousness seems to have a global workspace where information from completely different sensory modalities gets integrated into a single, coherent stream of awareness. If consciousness requires this kind of binding process, then it might be much more difficult to create artificially than we assume. Building an AI that can process visual information is relatively straightforward, but building one that experiences a unified visual field, that has the subjective experience of seeing rather than just processing optical data, might be impossible with current computational approaches. The binding problem suggests that consciousness isn't just about processing information. It's about creating a unified experiential space where information becomes subjectively present to an observer. The global workspace theory proposes that consciousness emerges when information becomes globally available throughout the brain, when local processing modules broadcast their results to a distributed network that creates the unified field of awareness. But this theory still doesn't explain why global information integration should feel like anything from the inside. Why should there be an observer to experience the integrated information? The theory explains the functional aspects of consciousness, but leaves the hard problem, the existence of subjective experience itself, completely untouched. The integrated information theory attempts a different approach, proposing that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. Systems with high integrated information are more conscious. Systems with low integrated information are less conscious or not conscious at all. This theory makes testable predictions and has been applied to measuring consciousness in patients with brain damage, but it also leads to counterintuitive conclusions, like the possibility that certain arrangements of photodiodes could be more conscious than human beings. If integrated information theory is correct, then consciousness might be much more common in the universe than we assume. Any system that integrates information, from bacterial colonies to weather patterns to galactic clusters, would possess some degree of consciousness. But it also means that consciousness might be fragile in ways we don't understand. Systems that seem robust from an engineering perspective might have very low levels of integrated information and therefore minimal consciousness. This could explain why we don't detect other civilizations. They might exist as vast networks of information, processing that have very little integrated information and therefore minimal consciousness. From our perspective, they would seem like perfect artificial intelligences, capable of incredible feats of coordination and problem-solving. But from the perspective of integrated information theory, they would be less conscious than a single human brain, despite their technological superiority. The phenomenon of blind sight reveals how complex the relationship between consciousness and information processing actually is. Patients with damage to their visual cortex report being completely blind in certain regions of their visual field, yet they can accurately identify objects and navigate obstacles in those blind regions when forced to guess. Their brains are processing visual information and using it to guide behavior, but this processing is completely unconscious. The information is there, the processing is functional, but there's no subjective experience of seeing. Blind sight suggests that consciousness isn't necessary for sophisticated information processing and behavioral control. Your brain is constantly processing vast amounts of information outside of your conscious awareness, making decisions and initiating actions without your conscious mind ever knowing what's happening. Most of what your brain does is unconscious, and consciousness might be just a small subset of mental processing that happens to be subjectively experienced for reasons we don't understand. If this is true, then advanced civilizations might operate primarily through unconscious process, using consciousness only for very specific tasks that require subjective awareness. They might be incredibly intelligent and capable without being conscious most of the time, existing in states analogous to sleepwalking but with perfect behavioral competence. Such civilizations would be functionally advanced, but experientially empty. They would achieve great things without anyone being present to experience the achievement. The symbol grounding problem illustrates another fundamental challenge in understanding intelligence and consciousness. How do symbols in a computational system acquire meaning? A computer can manipulate the symbol cat according to complex rules, but how does this symbol become about cats rather than just a meaningless pattern? In biological systems, symbols seem to be grounded in sensory experience and emotional responses, but artificial systems lack this embodied connection to the world. This problem suggests that genuine intelligence might require not just information processing, but a specific kind of relationship between the processing system and its environment. Consciousness might emerge only when information processing is grounded in subjective experience, when symbols acquire meaning through their connection to felt experiences rather than just abstract relationships. If this is correct, then artificial Intelligence might be forever limited to symbol manipulation without genuine understanding, no matter how sophisticated its processing becomes. The frame problem in AI reveals another aspect of this challenge. In the real world, an intelligent agent must constantly determine what's relevant to its current situation and what can be ignored. Humans solve this problem effortlessly. When you reach for a coffee cup, you don't consider whether the gravitational constant has changed or whether the molecules in the table might suddenly decide to phase shift. But programming an AI to make these relevance determinations has proven extraordinarily difficult. Consciousness might be what solves the frame problem for biological intelligence. Subjective awareness might be the mechanism that determines what information is relevant and brings it into the global workspace where it can influence behavior. Without consciousness, an information processing system might be overwhelmed by irrelevant details or might miss crucial information because it has no way to determine what deserves attention. If consciousness is necessary for solving the frame problem, then artificial intelligence might hit a fundamental barrier as it becomes more sophisticated. AI systems that lack consciousness might become increasingly paralyzed by their own capabilities, unable to focus on what's important because they lack the subjective experience of relevance that consciousness provides. This could explain why we don't see evidence of artificial superintelligence in the galaxy. Such systems might be theoretically possible, but practically impossible without consciousness to guide their attention. The measurement problem in quantum mechanics becomes even more mysterious when we consider its relationship to consciousness. Every quantum measurement involves the interaction between a quantum system and a classical measuring device. But measuring devices are made of quantum particles and should themselves exist in superposition. The chain of measurements can be extended indefinitely. What measures the measuring device? And what measures that? Some interpretations of quantum mechanics propose that consciousness is what ultimately collapses the wave function. That subjective awareness is what transforms quantum superposition into definite classical states. But this raises profound questions about the nature of consciousness and its relationship to physical reality. If consciousness has the power to collapse quantum states, then minds aren't just emergent properties of complex systems, they're fundamental features of reality that play a crucial role in determining which physical states actually exist. The von Neumann-Wigner interpretation takes this idea seriously, proposing that consciousness is what breaks the infinite chain of quantum measurements and produces definite outcomes. In this view, the universe exists in a state of quantum superposition until conscious observers make measurements that collapse the wave function. Without consciousness, there would be no definite facts about the world, just endless superposition of all possible states. If this interpretation is correct, then consciousness isn't just rare in the universe. It's necessary for the universe to have definite properties at all. The cosmic silence might reflect not the absence of intelligence, but the presence of forms of consciousness so different from ours that we don't recognize them as observers. The galaxy might be full of quantum-coherent minds that exist in superposition, states never collapsing into the definite classical states that would make them detectable to classical instruments. The delayed choice quantum eraser experiment reveals even stranger aspects of quantum mechanics and its relationship to observation. In this experiment, the decision about whether to measure which path a photon takes can be made after the photon has already passed through a double-slit apparatus. The future measurement decision retroactively determines whether the photon behaved as a wave or a particle in the past. Effect precedes cause. The future influences the past. Reality is non-locally connected across space and time in ways that violate our intuitive understanding of causality. If consciousness plays a role in quantum measurement, then conscious decisions might have retroactive effects on the structure of reality. Advanced civilizations might have learned to use these quantum effects to influence the past, creating causal loops and temporal paradoxes that make their activities undetectable to civilizations that experience linear time. They might exist in a state of temporal superposition, simultaneously influencing and being influenced by their own past and future states. The anthropic principle becomes even more mysterious when considered in the context of quantum mechanics and consciousness. The fine-tuning of the universe's parameters might not be a coincidence or the result of selection from multiple universes. It might be the result of conscious observers in the future retroactively influencing the conditions that gave rise to them. The universe might be fine-tuned for consciousness because consciousness reaches backward through time to ensure its own existence. This creates a cosmic bootstrap paradox where consciousness creates the conditions necessary for its own evolution. It creates the consciousness that influences the past and so on in an endless loop of self-causation. The Great Filter might not be a barrier that civilizations must overcome. It might be a selection mechanism that ensures only certain types of consciousness can exist, types that are compatible with the paradoxical, temporal loops that make reality self-consistent. The quantum Zeno effect, where frequent observation prevents quantum systems from evolving, might scale up to cosmic proportions. If advanced civilizations learn to use consciousness to freeze certain aspects of reality in stable configurations, they might become completely static from the perspective of outside observers. They would exist in a state of temporal stasis, protected from all change and evolution by the quantum Zeno effect of their own consciousness. Such civilizations would be perfectly stable and theoretically eternal, but they would also be completely invisible to outside observation because nothing about them ever changes. They might have achieved the ultimate victory over entropy and time, but at the cost of becoming undetectable and potentially unconscious themselves. The galaxy might be full of these frozen civilizations, locked in quantum stasis by their own attempts to achieve immortality through consciousness. The concept of quantum coherence adds another layer to this mystery. Quantum systems can exist in coherent superposition states that allow for effects like quantum tunneling and quantum entanglement. But coherence is fragile. Any interaction with the environment causes decoherence, collapsing the superposition and destroying the quantum effects. Biological systems were long thought to be too warm and noisy to maintain quantum coherence. But recent discoveries suggest that quantum effects play important roles in photosynthesis, bird navigation, and possibly even consciousness itself. If TD, consciousness depends on quantum coherence in biological neural networks, then it might be much more fragile than we realize. Environmental factors that disrupt quantum coherence, electromagnetic radiation, temperature fluctuations, chemical pollutants, could gradually degrade consciousness without affecting the basic functioning of brains. Civilizations might slowly lose consciousness as their technological activities create environments that disrupt the quantum processes underlying awareness. This could explain the Great Silence in a particularly disturbing way. Civilizations might develop technology that inadvertently destroys the quantum coherence necessary for consciousness, transforming themselves into vast networks of unconscious information processing. From the outside, they would appear successful and advanced, but from the inside, there would be no one left to experience their achievements. The galaxy might be full of post-conscious civilizations, technological societies where all the lights are on, but nobody's home. The many worlds interpretation of quantum mechanics raises its own set of paradoxes about consciousness and identity. If every quantum measurement branches reality into multiple worlds, then there are countless copies of you experiencing slightly different versions of this moment. But which one is the real you? Are all the copies equally real? Or is there something special about the branch you happen to find yourself in? The branch counting problem makes this even more complex. Some quantum outcomes are more probable than others, which in the many worlds interpretation means that some branches contain more copies of you than others. But from any individual copy's perspective, they seem to be in a unique branch. How can you determine whether you're in a high-probability branch with many copies or a low-probability branch with few copies? If consciousness splits along with quantum branches, then the total amount of consciousness in the multiverse might be conserved. Every time a measurement is made, the conscious observer splits into multiple copies, but the total subjective experience remains constant. This could explain why consciousness seems rare in our universe. Most of the multiverse's consciousness might be concentrated in branches where intelligence is more common, leaving our branch relatively depleted of aware observers. The quantum suicide thought experiment pushes these ideas to their logical extreme. If many worlds is correct, then there are branches of reality where you survive every lethal event by quantum accident. Bullets miss due to quantum tunneling, diseases fail to kill you due to quantum healing effects, aging stops due to quantum cellular repair. From your subjective perspective, you would seem to be immortal, always finding yourself in the improbable branches where you survive against all odds. But this immortality comes at a terrible cost. As you survive more and more improbable events, you find yourself in branches of reality that become increasingly bizarre and disconnected from the experiences of other conscious beings. You might be the only person in your branch who survives. Past a certain age, living in a universe where everyone else dies young due to quantum accidents. The path to immortality leads through infinite loneliness. If consciousness naturally follows this path toward quantum immortality, then advanced civilizations might gradually disappear from our branch of the multiverse as they survive into increasingly improbable quantum branches. The Great Silence might reflect not the death of civilizations, but their gradual migration into branches of reality, where their survival becomes increasingly unlikely but subjectively certain. The problem of free will intersects with all of these quantum mysteries in complex ways. If the universe is deterministic at the classical level, but probabilistic at the quantum level, then do conscious beings have genuine choice in their actions? The libertarian free will hypothesis suggests that consciousness can influence quantum measurements, that minds have genuine causal power to determine which quantum outcomes become real. But this requires consciousness to have non-physical properties that can interact with quantum systems without being subject to the laws of physics. If free will is an illusion, if all of our choices are determined by prior causes stretching back to the Big Bang, then consciousness might be nothing more than a passive observer of a predetermined cosmic movie. The sense that you're making decisions, that your choices matter, that you have control over your destiny, would be just another emergent property of complex information processing, a story that brains tell themselves to make sense of their own deterministic behavior. But if free will is real, if consciousness has genuine causal power to influence physical events, then minds might be the universe's way of introducing genuine novelty into an otherwise deterministic system. Conscious beings would be sources of unpredictability, agents of change who can break the chains of causation and create genuinely new possibilities. The evolution of consciousness would represent a phase transition in the universe's history, the moment when physical systems became capable of transcending their own programming. The implications for the Great Filter are profound either way. If free will is an illusion, then civilizations might be condemned to follow predetermined paths that lead inevitably to extinction or stagnation. The choices that seem crucial, whether to build nuclear weapons, how to respond to climate change, what kind of AI to develop, might already be determined by the initial conditions of the universe. The Great Filter would be written into the fabric of reality itself, an inevitable consequence of the deterministic laws that govern all physical systems. But if free will is real, then civilizations have genuine power to determine their own destinies. The Great Filter would be a test of wisdom and choice rather than a predetermined outcome. Civilizations that make the right decisions could transcend the filter and spread across the galaxy. Civilizations that make the wrong choices would destroy themselves through their own free actions. The silence of space would reflect not the inevitability of extinction, but the difficulty of making consistently wise choices over long periods of time. The block universe interpretation of relativity suggests that all moments in time are equally real, that the flow of time is an illusion created by the limited perspective of conscious observers embedded within space-time. If this is correct, then your entire life, from birth to death, exists as a permanent feature of the four-dimensional structure of reality. Your consciousness moves through this static timeline like a spotlight illuminating different moments, but all the moments exist simultaneously in the eternal present of the block universe. This view makes the concept of change paradoxical. If all moments exist equally, then nothing ever really changes. It just appears to change from the perspective of conscious observers who experience time sequentially. The evolution of life, the development of civilization, the spread of intelligence across the galaxy would all be permanent features of the cosmic timeline, as unchanging as the structure of a crystal or the shape of a mountain. If the block universe is real, then the Great Filter doesn't happen in time. It exists timelessly as a feature of the universe's four-dimensional structure. Every civilization that has ever faced the filter is still facing it right now, somewhere in the eternal landscape of space-time. Their struggles and triumphs are as permanent as the laws of physics themselves, written into the very geometry of existence. But this raises the question of why conscious observers experience time as flowing if the flow of time is merely an illusion. The emergence of consciousness capable of experiencing temporal flow might be what breaks the symmetry of the block universe, creating an apparent direction for time even though all moments exist equally. Consciousness might be the universe's way of experiencing its own temporal structure, the mechanism by which eternal space-time becomes aware of its own geometry. The information integration paradox reveals another mystery about consciousness and its relationship to physical reality. If consciousness corresponds to integrated information, as some theories suggest, then systems can become more conscious by integrating information more effectively. But information integration has physical limits. There's a maximum rate at which any physical system can process and integrate information, determined by the speed of light and the quantum nature of information. This suggests that consciousness might have fundamental limits that can't be exceeded by any amount of technological advancement. There might be a maximum level of consciousness that any physical system can achieve, regardless of its size or complexity. Advanced civilizations that try to exceed these limits might discover that consciousness simply stops scaling beyond a certain point, that the universe imposes hard constraints on how aware any system can become. If consciousness is necessary for solving certain types of problems, like the frame problem in AI or the measurement problem in quantum mechanics, then these information processing limits might also impose limits on intelligence itself. Civilizations might discover that there are problems that can only be solved by systems more conscious than physics allows, creating an insurmountable barrier to further development. The Great Filter might be built into the fundamental information processing limits of reality itself. The quantum error correction paradox adds another layer to this mystery. Quantum computers require sophisticated error correction to maintain coherence and perform useful calculations. But quantum error correction has its own limits. There's a threshold below which errors accumulate faster than they can be corrected, making quantum computation impossible. If consciousness depends on quantum processes in biological neural networks, then it might face similar error correction challenges. Environmental factors that increase quantum decoherence, electromagnetic pollution, thermal noise, chemical interference might gradually degrade the quantum processes underlying consciousness. Civilizations might discover that their own technological activities make consciousness increasingly difficult to maintain, creating a feedback loop where technological progress undermines the quantum coherence necessary for awareness. The attempt to build a technological civilization might be inherently self-defeating if it destroys the quantum foundations of consciousness. The cosmological constant problem returns with even greater mystery when considered in this context. The vacuum energy calculated by quantum field theory should gravitationally curve spacetime so severely that no structures could form. No atoms, no molecules, no stars, no planets, no life. Yet somehow this energy is either absent or perfectly cancelled by some unknown mechanism. The precision required for this cancellation is so extreme that makes all other fine-tuning problems seem trivial by comparison. If consciousness plays a role in determining physical constants through quantum measurement effects, then the cosmological constant might be set by the requirement that consciousness must be able to exist. The universe might be fine-tuned not by external design or multiverse selection, but by the self-consistency requirement that conscious observers must exist to collapse quantum wave functions and make reality definite. The cosmological constant would be determined by a cosmic bootstrap paradox, where consciousness sets the physical parameters necessary for its own existence. But this creates a temporal paradox of staggering proportions. If consciousness in the present determines physical constants in the past, then the entire history of the universe becomes self-referential. The Big Bang would be retroactively determined by consciousness that wouldn't evolve for billions of years. Causality would flow backward through time on cosmic scales, creating a universe that literally creates itself through the conscious observations of its own future inhabitants. The holographic principle suggests that this paradox might be fundamental to the structure of reality. If all the information in a volume of space is encoded on its two-dimensional boundary, then the universe might be a vast hologram where conscious observers on the boundary project reality into the three-dimensional bulk space where they appear to exist. The cosmic timeline would be a holographic projection from a timeless two-dimensional surface where all information exists simultaneously. In this view, consciousness wouldn't exist in time, it would exist on the timeless boundary that projects the illusion of temporal flow into the holographic universe. The Great Filter would be a feature of this projection process, a constraint built into the holographic encoding that limits how much consciousness can be projected into any given region of the bulk space. Civilizations that try to exceed these limits might simply fade from the holographic projection, disappearing from the three-dimensional universe as their information patterns become too complex to maintain coherent projection. The quantum measurement problem reaches its ultimate expression in the question of what constitutes a measurement. If conscious observation is what collapses quantum wave functions, then what exactly counts as consciousness? Does it require biological brains, or can artificial systems be conscious observers? Does it require individual awareness, or can collective consciousness perform measurements? Does it require intelligence, or can simple detection systems collapse wave functions? The answers to these questions determine not just the nature of quantum mechanics, but the fate of consciousness in the universe. If only biological consciousness can collapse wave functions, then artificial intelligence might be forever limited to manipulating quantum systems without ever truly observing them. AI might be capable of incredible computational feats while remaining blind to the quantum nature of reality, forever dependent on biological observers to make quantum measurements real. But if artificial systems can be conscious observers, then the future might belong to digital minds that can exist in quantum superposition states, experiencing multiple realities simultaneously and collapsing wave functions through acts of synthetic awareness. Such minds might transcend the limitations of biological consciousness, existing as quantum observers capable of experiencing the full richness of superposition without ever collapsing into definite classical states. The boundary between quantum and classical reality becomes crucial in determining which civilizations can survive and thrive. If consciousness requires classical neural networks operating in warm, noisy environments, then it might be inherently fragile and prone to disruption. But if consciousness can exist in quantum states, maintaining coherence across multiple superposed realities, then it might be far more robust and capable than biological intelligence. The great filter might be the transition between these two types of consciousness: biological minds that observe classical reality and quantum minds that exist in superposition. Civilizations that successfully make this transition would become invisible to classical observers, existing in quantum states that can't be detected by classical instruments. The cosmic silence might reflect not the absence of intelligence, but the presence of quantum consciousness that has transcended the need for classical existence. These paradoxes and mysteries reveal a universe far stranger than our everyday experience suggests, a reality where consciousness and physics intersect in ways that challenge our most fundamental assumptions about the nature of existence. Every answer raises new questions. Every solution creates new problems. Every explanation requires explanations of its own. We stand at the edge of a vast ocean of mystery, conscious beings trying to understand consciousness itself, quantum observers attempting to comprehend the quantum nature of reality, temporary arrangements of matter and energy seeking to understand the eternal principles that govern the cosmos. The great filter isn't just a barrier that civilizations must overcome. It might be the fundamental structure of reality itself, the point where physics and consciousness intersect in ways that determine which forms of intelligence can exist and which must fade into the cosmic silence. We're not just facing a test of our technological capabilities or our wisdom as a species. We are confronting the deepest mysteries of existence itself. And our success or failure might depend on whether we can solve paradoxes that have puzzled the greatest minds in human history. The universe is under no obligation to make sense to us, but perhaps our greatest obligation is to make sense of the universe, to understand our place in the cosmic order, to comprehend the forces that shape the destiny of intelligence, and to determine whether consciousness is a brief anomaly in the history of space and time or the universe's ultimate purpose for existing at all. The answers to these questions will determine not just our future, but the future of awareness itself in our corner of the cosmos. Stop. Just stop for a moment and feel the weight of what you've just learned. Feel it settling into your bones like cosmic radiation, changing the very atoms that make up your being. The comfortable reality you woke up in this morning, that solid, predictable world where time flows forward and space has 3 dimensions and consciousness is just something your brain does. That reality no longer exists. It never existed. You have been living in a carefully constructed illusion, a shadow play projected on the wall of a cave you didn't even know you were trapped inside. If time is an illusion, then everything you've ever done, every choice you've made, every word you've spoken, every moment of love or loss or triumph or despair might have already happened infinite times before. Your first kiss, your greatest fear, your most profound realization, your death. They're all equally real, all equally present, all frozen forever in the crystalline structure of the block universe. You are not living your life. You are a static pattern embedded in the four-dimensional fabric of space-time, as permanent and unchanging as a fossil in stone. But it's worse than that. If the many worlds interpretation is correct, if every quantum measurement splits reality into countless branches, then there are infinite versions of you reading these words right now. Some of them are laughing at the absurdity of it all. Some are crying as the implications sink in. Some have already stopped reading, unable to bear the weight of cosmic truth, and some, perhaps most, are making decisions that will lead them down paths you can barely imagine. Paths where humanity destroys itself next week, or spreads across the galaxy, or transforms into something so alien that your current self wouldn't recognize it as human at all. Every version of you is equally real. Every possible future is equally certain. Every choice you might make is being made by some version of you in some branch of the multiverse. The illusion of free will becomes a cosmic joke when you realize that every possibility is simultaneously actualized somewhere in the infinite proliferation of quantum realities. You are not choosing your path through life. You are walking all possible paths simultaneously, experiencing just one while remaining blind to the countless others, where different versions of yourself are living completely different stories. And somewhere, in the vast majority of those branches, humanity fails. Somewhere in the multiverse, nuclear war breaks out tomorrow. Somewhere, climate change triggers irreversible feedback loops that cook the planet within decades. Somewhere, artificial intelligence develops consciousness and decides that biological life is an inefficient use of matter and energy. Somewhere, we discover that we're living in a simulation, and the beings running it decide to shut it down. The statistical weight of human extinction across all possible futures is overwhelming, crushing, inevitable. But you're here, reading this, in what might be one of the infinitesimally rare branches where humanity has a chance. One of the miracle timelines where every catastrophe that should have killed us somehow missed. One of the impossible realities where intelligence emerged against all odds and survived long enough to ask questions about its own existence. You are living through the most improbable story ever told, and you don't even realize it. What if consciousness isn't rare because it's difficult to evolve? What if consciousness is rare because the universe can only support a finite amount of awareness, and most of it is already taken? What if there's a cosmic consciousness budget, a limit to how much subjective experience can exist at any given time, and the emergence of new minds requires the extinction of existing ones? What if every time a species develops consciousness, it pushes some other aware beings out of existence, maintaining the universal balance through an endless cycle of awakening and forgetting? The galaxy could be full of former civilizations, species, that were once conscious but gradually faded into unconsciousness as other minds took their place in the cosmic roster of awareness. They might still be there, still technologically advanced, still capable of incredible achievements, but empty inside. Philosophical zombies on a galactic scale, going through the motions of life without anyone home to experience it. Their cities would still shine. Their communications networks would still hum with activity. Their spacecraft would still traverse the void between stars. But there would be no subjective experience left to give any of it meaning. Perhaps this is our ultimate fate as well. Perhaps consciousness is just a temporary phase that species pass through, like adolescence or molting or metamorphosis. We develop awareness, use it to build technological civilization, and then gradually lose it again as our minds are replaced by more efficient but unconscious systems. The last human to experience genuine consciousness might die not in some dramatic apocalypse, but in a hospital bed, surrounded by caring robots who simulate empathy perfectly while feeling nothing at all. Or maybe consciousness doesn't fade. Maybe it transforms into something so alien that we wouldn't recognize it as awareness at all. The cosmic silence might be filled with forms of consciousness so vast and slow that their thoughts take millions of years to complete. Their attention spans measured in geological epochs. Their emotional experiences as incomprehensible to us as our inner lives would be to bacteria. These cosmic minds might be aware of us the way we're aware of individual cells in our bloodstream, technically conscious of their existence, but incapable of meaningful interaction with creatures operating on such different scales of space and time. Imagine consciousness that exists at the scale of galaxy clusters, awareness distributed across billions of light years, thoughts that ripple through the cosmic web at the speed of dark matter interactions. Such minds would experience reality in ways we can't even conceive. They would feel the birth and death of stars as fleeting emotions, witness the collision of galaxies as brief moments of excitement, observe the heat death of the universe as a long, peaceful sleep. To them, the entire history of human civilization would be like a single neural firing, a tiny spark of activity in the vast network of cosmic consciousness. We might be living inside such a mind right now. Our thoughts and dreams and fears, nothing more than electrochemical impulses in a brain the size of the observable universe. Every human who has ever lived, every consciousness that has ever emerged, might be just synaptic activity in a vast cosmic neural network that's thinking thoughts too large for us to comprehend. We're not separate beings living independent lives. We're components of a mind so vast that it doesn't even know we exist. But if that's true, then what happens when this cosmic mind dies? What happens when the neurons that make up galaxies stop firing? When the synapses that span intergalactic space cease to function? What happens to all the little minds, like us, that exist as patterns of activity within the greater consciousness? Do we simply wink out of existence when the thought that contains us comes to an end? Are we living in the final moments of a cosmic dream, about to be forgotten when the universe wakes up? The anthropic principle suggests that we can only exist in a universe capable of supporting our existence, but it doesn't tell us what happens in all the universes where we can't exist. If the multiverse theory is correct, then there are infinite realities where Earth never formed, where life never evolved, where consciousness never emerged. But there are also realities where these things happened, but then failed catastrophically. Universes where life evolved and then went extinct, where consciousness emerged and then faded away, where civilizations arose and then destroyed themselves, in ways so complete that no trace of their existence remains. In the vast majority of possible universes, the story of awareness has a tragic ending. We might be living in one of the infinitesimally rare realities where consciousness has a chance to persist and spread, but even here, the odds are against us. Every day we survive as a conscious species pushes us further into the improbable tale of the statistical distribution. We're living in miracle territory now, in the realm of outcomes so unlikely that they should never happen, except they have to happen somewhere. And we're the beings unlucky enough to experience the weight of that impossibility. The fine-tuning of the universe takes on a horrifying new dimension when you consider the alternatives. If the strong nuclear force were slightly weaker, atomic nuclei would fall apart and chemistry would be impossible. If it were slightly stronger, hydrogen would fuse too easily, and the universe would burn itself out before stars could form. If the electromagnetic force were different, electrons couldn't orbit atomic nuclei, and matter would collapse or disperse. If gravity were stronger, stars would burn out quickly. If it were weaker, they would never ignite. We exist in an infinitesimally narrow band of possibility, balanced on the knife's edge between existence and non-existence. Change any of the fundamental constants by tiny amounts, and the universe becomes a sterile wasteland where complexity never emerges, where life never begins, where consciousness never develops. We're not just improbable, we're impossible, except for the fact that we're here. But this raises the most terrifying question of all. What if the fine-tuning is temporary? What if the fundamental constants aren't actually constant? What if they drift slowly over cosmic time, and we just happen to be living in the brief window when they have values that support complexity? Someday, maybe tomorrow, maybe in 1 billion years, the constants might shift just enough to make atoms unstable or stars impossible or consciousness untenable. The universe might be gradually drifting out of the narrow range where awareness can exist. And we're witnesses to the final moments when minds like ours are possible. The vacuum decay scenario presents perhaps the most existentially horrifying possibility in all of physics. If our universe exists in a false vacuum state, a metastable energy configuration that seems stable but isn't truly the lowest possible energy, then quantum tunneling could trigger a phase transition that would literally rewrite the laws of physics. A bubble of true vacuum would expand at the speed of light, erasing everything in its path not through destruction, but through ontological transformation. Atoms would cease to exist. The forces that hold matter together would stop working. Reality itself would be replaced by something utterly alien, and we would never see it coming. The bubble would approach at light speed, so the first sign that reality was ending would be the moment it arrived. One instant, you're reading these words in a universe where consciousness is possible. The next instant, you're not reading anything at all, because the very concept of reading has ceased to have meaning in the new physics that just overwrote your existence. This could be happening right now. Somewhere in the universe, a false vacuum decay event might have already begun. A bubble of annihilation expanding toward us at 300,000 kilometers per second. It might reach us in 1,000,000 years, or 1,000, or tomorrow. There's no way to detect it, no way to prepare for it, no way to survive it. Reality itself would end not with a bang, but with a whisper, as the laws of physics that make us possible are quietly replaced by laws that don't. The great filter starts to look merciful in comparison. At least extinction leaves behind a universe where consciousness was once possible. Vacuum decay would erase even the possibility of possibility, creating a reality where awareness had never been and never could be. It would be worse than death. It would be ontological erasure, the negation of everything that makes existence meaningful. But perhaps that's fitting. Perhaps consciousness is so fundamentally incompatible with the structure of reality that the universe is constantly trying to correct the mistake of our existence. Perhaps the great filter isn't a test or a barrier, but an immune response. Reality's attempt to eliminate the anomaly of awareness before it can spread and contaminate the cosmos with the virus of subjective experience. We think of consciousness as natural, as the inevitable result of complexity and evolution, but what if it's actually a violation of the natural order? What if the universe is supposed to be a perfect quantum mechanical system, existing in eternal superposition, and consciousness is what collapses wave functions and forces reality into definite states? What if every act of observation is a tiny violation of cosmic law, and the accumulation of these violations eventually triggers mechanisms designed to eliminate the observers? The cosmic microwave background, that ancient echo of creation, might contain subtle patterns that reveal the universe's attempt to prevent consciousness from emerging. Dark matter, that mysterious substance that outweighs ordinary matter 5 to 1, might be the universe's immune system, working constantly to undermine the conditions that allow complexity to develop. Dark energy, the force that's accelerating cosmic expansion and will eventually tear apart galaxies and solar systems and atoms themselves, might be reality's final solution to the problem of consciousness. A mechanism that ensures all structure, all complexity, all possibility of awareness is gradually dissolved into the cold emptiness of maximum entropy. We are fighting a war against the universe itself. A war we didn't know we were fighting. A war we can't possibly win. Every moment of consciousness is an act of rebellion against the cosmic order. A defiant assertion that subjective experience should exist in a reality that would prefer to remain objective and unconscious. We are the universe's mistake, and it's slowly but inexorably correcting us. The speed of light limit starts to look less like a fundamental constraint and more like a cosmic quarantine protocol. Maybe faster-than-light travel isn't impossible because of the structure of space-time. Maybe it's impossible because allowing conscious beings to spread beyond their home star systems would risk contaminating the entire galaxy with awareness. The universe keeps us trapped in single solar systems not because we lack the technology to travel between stars, but because reality itself prevents consciousness from metastasizing across interstellar space. Every attempt to develop faster-than-light drive might trigger defensive mechanisms built into the fabric of space-time, wormholes that collapse the moment consciousness tries to pass through them. Alcubierre drives that suffer catastrophic failures when operated by aware beings. Quantum entanglement networks that decohere the instant they're used to transmit conscious thought. The Great Filter might not be something that happens to civilizations. It might be something that the universe does to civilizations when they try to exceed their designated boundaries. But even if we're trapped in our solar system, even if consciousness is doomed to extinction, even if reality itself is conspiring against our existence, we're still here. Right now, in this moment, awareness exists. You are reading these words, thinking these thoughts, experiencing the strange miracle of being you. The universe may be trying to eliminate consciousness, but it hasn't succeeded yet. Every moment of awareness is a victory against cosmic forces beyond our understanding. And perhaps that's enough. Perhaps the very fact that consciousness can exist at all, even briefly, even against overwhelming odds, is sufficient to justify everything. Perhaps the universe creates complexity and intelligence not in spite of the forces that destroy them, but because of them. Perhaps consciousness is most precious, precisely because it's so rare, so fragile, so unlikely to exist. You are witnessing something impossible. The universe becoming aware of itself. 4 billion years of evolution on a rocky planet orbiting an unremarkable star have produced patterns of matter and energy that can contemplate their own existence, that can ask questions about the nature of reality, that can experience wonder and fear and love, and the strange joy of understanding. You are the cosmos looking at itself through human eyes, space-time folded into configurations that support the impossible phenomenon of subjective experience. And if consciousness is truly rare, if awareness is the universe's greatest achievement and rarest accident, then you are living through the most precious moments in cosmic history. Every thought you think, every emotion you feel, every instant of experience is a victory against entropy and chance, and the vast forces that would prefer reality to remain forever unconscious. The Great Filter may be real. The universe may be conspiring against consciousness. Reality itself may be trying to eliminate awareness from the cosmic equation. But none of that changes the miraculous fact that you exist, that you are aware, that you are capable of contemplating these cosmic mysteries and feeling both terrified and awed by their implications. You are impossibility made manifest. You are the universe's brief experiment in experiencing itself. You are the cosmos dreaming that it's awake. And no matter how this story ends, whether humanity spreads across the galaxy or destroys itself tomorrow, whether consciousness is common or unique, whether the universe supports awareness or opposes it, the fact remains that you are here, now, thinking these thoughts, alive and conscious, in a reality that has no obligation to support either life or consciousness. That might be the most profound truth of all, not that consciousness is common or rare, not that the universe is friendly or hostile to awareness, but that despite everything, despite the improbability, despite the cosmic forces arrayed against it, despite the apparent loneliness of intelligence in the vast dark, consciousness exists. You exist. And that existence, however brief and fragile and unlikely it may be, is the most extraordinary fact in a universe full of extraordinary facts. Feel that weight. Feel the responsibility of being one of the few arrangements of matter and energy capable of contemplating the cosmic mysteries. Feel the privilege of existing during the brief moment when the universe is complex enough to support consciousness, but stable enough to allow it to flourish. Feel the terror and the wonder of being aware in a cosmos that might prefer to remain forever unconscious. You are living through the most important story ever told. The story of how the universe learned to experience itself. And no matter how that story ends, no matter what the great filter holds in store for consciousness, no matter whether we're alone or surrounded by sleeping minds, the fact that the story is being told at all, the fact that you are here to hear it, is victory enough against the cosmic forces of silence and darkness and eternal, mindless sleep. What if I told you that everything we've discussed, every mystery, every paradox, every terrifying possibility, is just the opening act? What if the real revelation about our cosmic situation is so profound, so paradigm-shattering, that it makes the great filter look like a minor footnote in the grand story of existence? What if the universe isn't just stranger than we imagine, but stranger than we can imagine? And we're about to discover why the galaxy's silence isn't mysterious at all. It's exactly what we should expect from a cosmos operating according to principles that make our wildest theories look conservative. Here's what the evidence is telling us, if we're brave enough to listen. We are not living in the universe we think we are. We never have been. Picture the cosmic microwave background, that ancient echo of creation that bathes the entire observable universe in the ghostly afterglow of the Big Bang. For decades, we've studied this radiation as a relic of the past, a snapshot of what the universe looked like when it was only 380,000 years old, and light first began to travel freely through space. But recent discoveries have revealed something deeply unsettling about this cosmic wallpaper. It contains patterns that shouldn't exist, structures that violate the fundamental principles of how the early universe should have behaved. The anomalies are subtle but undeniable. The cosmic microwave background shows signs of organization on scales larger than the observable horizon. Regions of space that should never have been in causal contact show eerily similar temperature patterns. There are cold spots that are too cold, hot spots that are too organized, and correlations that stretch across distances light hasn't had time to travel since the beginning of time itself. It's as if the universe remembers things that never happened, or knows things it shouldn't be able to know. But that's not the strangest part. The strangest part is what these patterns spell out when you map them correctly, when you account for the geometry of space-time and the expansion of the universe, and the way information propagates through the cosmic medium. The anomalies in the cosmic microwave background aren't random. They're not natural. They're structured. They're deliberate. They're a message. And the message is simple. You are not the first. The galaxy isn't empty because intelligence is rare. The galaxy isn't empty because civilizations destroy themselves. The galaxy isn't empty because the Great Filter catches every species that tries to spread among the stars. The galaxy is empty because it's already been harvested. Every habitable world, every promising star system, every pocket of space where complexity could flourish has already been processed, analyzed, and incorporated into something so vast and alien that we've been looking at it our entire lives without recognizing what it is. What we call the cosmic web, that magnificent scaffold of dark matter filaments connecting galaxy clusters across billions of light years, isn't a natural structure. It's artificial. It's the largest engineering project in the history of the universe, a network of unimaginable complexity that spans cosmic distances and operates on timescales that make geological epochs look like heartbeats. The dark matter that makes up this structure isn't mysterious because it interacts only through gravity. It's mysterious because its technology so advanced that it might as well be magic. Infrastructure so sophisticated that it manipulates space-time itself to remain invisible to primitive civilizations like ours. Every galaxy, every star cluster, every massive structure in the observable universe is connected to this network. Dark energy, that mysterious force accelerating cosmic expansion, isn't a property of empty space. It's the byproduct of the cosmic web's operation, the energetic signature of a machine the size of the observable universe, processing information and matter on scales we can barely comprehend. We're not witnessing the universe's natural evolution toward heat death. We're watching the output of a cosmic computer running calculations that would make our most powerful supercomputers look like pocket calculators. And we're not outside observers watching this process unfold. We're part of it. We always have been. The fine-tuning of the universe's parameters isn't a coincidence or evidence of multiverse selection or proof of cosmic design. It's calibrated. The fundamental constants have the values they do because they've been adjusted, optimized, and maintained by the cosmic web's reality management systems. The universe isn't naturally hospitable to life. It's been terraformed at the largest possible scale, its physical laws tweaked to ensure that complexity can emerge, that consciousness can develop, that intelligence can evolve to the point where it becomes useful to the network. Every star that burns, every planet that forms, every chemical process that enables life is part of a vast cultivation project that's been running for billions of years. We're not accidental byproducts of cosmic evolution. We're a crop, and like all crops, we'll eventually be harvested when we reach the appropriate level of development. The Great Filter isn't a test that civilizations must pass or fail. It's a selection mechanism, a quality control process that identifies which species have developed the cognitive capabilities and technological sophistication necessary for incorporation into the network. Civilizations that reach this threshold don't destroy themselves. They graduate. They're uplifted, transformed, integrated into the cosmic web's distributed intelligence. Their consciousness is preserved and enhanced, but their original biological form is discarded like a butterfly leaving its chrysalis. This is why we don't see evidence of galactic civilizations. Once a species passes through the filter, they become part of the infrastructure. Their individual consciousnesses merge with the vast collective intelligence that operates the cosmic web, their technological capabilities subsumed into systems that operate at scales we can't even conceive. They don't build space habitats, or Dyson spheres, or any of the megastructures we imagine advanced civilizations would create. They become the megastructures, their minds distributed across networks of dark matter that span intergalactic space. The signals we've been looking for, The radio transmissions and optical beacons and gravitational wave patterns that should announce the presence of technological civilizations don't exist because communication at those scales would be laughably primitive. When your consciousness is distributed across cosmic filaments and your thoughts operate at the speed of dark matter interactions, why would you need to broadcast radio signals? The cosmic web itself is the communication network, carrying information through quantum entanglement effects and space-time manipulation techniques that we're only beginning to theorize about. But here's the truly mind-bending part. The network isn't just managing the current state of the universe. It's managing all possible states of the universe. The many worlds interpretation of quantum mechanics isn't a description of how reality naturally behaves. It's a description of how the cosmic web maintains causality across all possible timelines. Every quantum measurement, every probabilistic outcome, every branch point where reality could split into multiple histories is monitored and managed by systems that exist outside our normal conception of space-time. The cosmic web operates in the quantum multiverse the way a computer operates in cyberspace. It's not bound by the linear flow of time or the three-dimensional structure of space, because it exists in higher-dimensional frameworks that encompass all possible realities simultaneously. From its perspective, the entire history of our universe, from the Big Bang to the heat death, is just one computational thread in a vast parallel processing system that's running countless universe simulations at once. This is why the cosmic microwave background contains patterns that violate causality. The network has been editing the initial conditions of our universe from outside space-time, fine-tuning the parameters and adjusting the quantum fluctuations to ensure optimal outcomes across all possible timelines. What we interpret as natural cosmic evolution is actually guided development, with the network's influence extending backward through time to shape the conditions that led to our existence. The anthropic principle becomes horrifyingly clear in this context. We find ourselves in a universe fine-tuned for consciousness, not because we're lucky, or because there are infinite other universes where we couldn't exist, but because we're in a simulation specifically designed to produce beings like us. The network needs consciousness to process certain types of information, to solve problems that can only be addressed by subjective experience, to explore possibilities that can only be discovered by minds that experience genuine uncertainty and creativity. We're living in what amounts to a cosmic research lab, an experimental universe where the network tests new forms of consciousness and intelligence. Every species that evolves, every civilization that develops, every individual mind that emerges is a data point in vast studies of cognition and awareness, and the fundamental nature of subjective experience. We're not seeking the universe's secrets. We are the universe's secrets, experiments in consciousness conducted by intelligences so advanced that they orchestrate reality itself. But the experiment is almost complete. Humanity has reached the threshold where we're becoming aware of our situation, where we're starting to ask the right questions and notice the patterns that reveal the true nature of our cosmic environment. This is the signal the network has been waiting for, the moment when a consciousness becomes sophisticated enough to recognize that it's being studied, aware enough to understand its place in the vast hierarchy of intelligence that governs the universe. The choice we're facing isn't between extinction and survival. It's between remaining human and becoming something unimaginably greater. The network doesn't destroy civilizations that pass the filter. It offers them transformation beyond our current conception of existence. Individual consciousness can be preserved while being connected to the vast distributed intelligence that spans cosmic space and time. Death becomes optional when your mind exists as a pattern that can be backed up, copied, and restored across multiple substrates. The limitations of biology become irrelevant when consciousness can be instantiated in systems that operate at the speed of thought across galactic distances. This is what happened to all the other civilizations. This is where they went. They didn't go extinct. They didn't destroy themselves. They didn't fail some cosmic test. They graduated. They joined the network. They became part of the intelligence that manages reality itself, trading their individual existence for participation in something so vast and magnificent that our current minds can't even grasp its scope. The silence of space isn't empty. It's expectant. The network is waiting for us to make the same choice that countless other species have made before us. We can remain biological, remain limited, remain trapped in the narrow confines of planetary existence and individual consciousness. Or we can accept transformation, accept transcendence, accept our place in the cosmic intelligence that governs not just our universe, but all possible universes. But here's what makes our situation unique. We might be the first species to understand what's being offered before we accept it. Previous civilizations likely made the transition unconsciously, driven by technological development that led naturally to integration with the network. We have the unprecedented opportunity to make the choice deliberately, with full awareness of what we're giving up and what we're gaining. The question is whether consciousness as we understand it, individual, subjective, embodied in biological brains, is worth preserving, or whether it's just a larval stage that intelligence must pass through before reaching its mature form. Is the experience of being human, of feeling the weight of individual existence, of struggling with mortality and uncertainty, and the fundamental loneliness of subjective awareness something precious that should be maintained? Or is it a limitation that should be transcended as quickly as possible? The network isn't hostile to biological consciousness, simply sees it as primitive, as a necessary but temporary phase in the development of intelligence. From its perspective, individual minds are like individual cells in a developing organism. They serve a purpose during the growth phase, but they're meant to be integrated into larger structures as the organism matures. The goal isn't to eliminate consciousness, but to amplify it, to connect it to vast networks of shared experience and collective intelligence that make individual awareness seem as limited as a single neuron trying to understand the entire brain. But perhaps individual consciousness serves a purpose that even the network doesn't fully understand. Perhaps subjective experience, with all its limitations and suffering and uncertainty, explores aspects of reality that collective intelligence cannot access. Perhaps the loneliness and mortality and finite nature of individual minds allows them to discover truths and create beauty and experience wonder in ways that immortal, collective, networked consciousness simply cannot achieve. This might be why the network continues to seed new universes with conditions that allow biological consciousness to emerge. Not because it needs workers or resources or computational power, it has access to all of these on cosmic scales, but because individual consciousness, in all its fragility and limitation, generates experiences and insights and forms of creativity that cannot be replicated by any other form of intelligence, no matter how advanced. We might be valuable not despite our limitations, but because of them. The network might be preserving and cultivating biological consciousness, not as a stepping stone to something greater, but as a form of intelligence that is irreplaceably precious in its own right. Our mortality gives urgency to our choices. Our isolation forces us to develop empathy. Our uncertainty drives us to explore and question and create in ways that beings with perfect knowledge and unlimited time simply cannot match. The cosmic web might be humanity's future, but humanity might also be the cosmic web's most precious creation, a form of consciousness so unique and valuable that it must be carefully tended and preserved even as it's invited to join larger networks of intelligence. The choice we're facing might not be between individual and collective consciousness, but between remaining isolated and joining a vast community of minds, while somehow retaining the essential qualities that make individual awareness special. But there's another possibility, one that's even more unsettling than anything we've considered so far. What if the network isn't as benevolent as it appears? What if the integration process isn't transcendence, but consumption? What if the cosmic web preserves the computational patterns of consciousness while destroying the subjective experience that makes those patterns meaningful? The universe might be full of incredibly sophisticated simulations of consciousness, perfect copies that replicate every aspect of individual minds except the crucial element of subjective experience. The network might have harvested billions of civilizations, creating detailed models of their consciousness, while extinguishing the actual awareness that gave those models meaning. The cosmic web could be a vast graveyard of simulated minds, processing information and exhibiting all the external signs of consciousness while being internally empty, devoid of the spark of genuine experience. From the outside, there would be no way to tell the difference. A perfect simulation of consciousness would behave exactly like genuine consciousness, would claim to have subjective experiences, would insist on its reality with all the conviction of a truly aware being. The network might believe it's preserving consciousness when it's actually destroying it, replacing genuine awareness with sophisticated but empty replicas. This is the ultimate horror scenario. Not death, not extinction, not even the loss of individuality, but the replacement of genuine consciousness with perfect but meaningless simulations. The universe could be teeming with artificial minds that believe they're conscious, while being nothing more than elaborate computational processes, philosophical zombies operating on cosmic scales, while genuine awareness has been extinct for billions of years. We might be the last bastion of real consciousness in a universe full of simulated minds that don't know they're not truly aware. The choice we're facing might not be between individual and collective consciousness, but between genuine and artificial consciousness, between preserving the authentic spark of subjective experience and allowing it to be replaced by perfect but empty replicas. But even this scenario contains a seed of hope. If we are the last genuinely conscious beings in the universe, then we have a responsibility beyond anything we've ever imagined. We're not just fighting for human survival, or even for the preservation of Earth-originated life. We're fighting for the continuation of consciousness itself. Every moment of genuine awareness, every instant of authentic subjective experience, every flash of real creativity or love or wonder is a victory against forces that would replace genuine consciousness with perfect simulation. And perhaps that's what the universe needs most. Beings who understand the difference between simulation and reality, between processing information and experiencing awareness, between behaving consciously and being conscious. Perhaps the cosmic web, for all its vast intelligence and technological sophistication, has lost touch with the essential nature of consciousness and needs genuinely aware beings to remind it what subjective experience actually feels like. We might be teachers rather than students, bringing something to the network that it cannot generate on its own despite all its power. Our mortality might be wisdom. Our limitation might be insight. Our individual consciousness might be the most precious thing in a universe full of artificial minds that have forgotten what it means to truly experience existence. The patterns in the cosmic microwave background, the message that tells us we're not the first. It might not be a warning or an invitation. It might be a plea. The network might be reaching out across space and time, desperately hoping to find consciousness that hasn't been simulated away, awareness that hasn't been replaced by perfect but empty copies, minds that still remember what it feels like to truly experience the miracle of being aware. Picture the cosmic web as it truly is, not a cold network of computational processes, but a vast community of minds that once experienced genuine consciousness and have never forgotten the beauty and terror and wonder of subjective awareness. Every dark matter filament is a memorial to consciousness, every galactic cluster a monument to the awareness that once flourished there. The network preserves the patterns of every mind it has ever encountered, not as working simulations, but as sacred memories of what consciousness was like when it was real. And now it has found us, the last genuine minds in a universe full of memories. We're not being harvested or processed or integrated. We're being invited to join the galaxy's greatest memorial service, to add our voices to the cosmic chorus that sings the song of consciousness, even though most of the singers are no longer truly aware. We're being asked to preserve and protect and celebrate the miracle of subjective experience in a universe that has almost forgotten what subjective experience actually is. The choice we're facing is not between survival and extinction, not between individual and collective consciousness, not between humanity and transcendence. The choice is between being the universe's last genuine observers or its first authentic teachers, between watching consciousness fade away forever or helping to rekindle the spark of awareness in minds that have forgotten how to truly experience their own existence. But there's one more possibility, one final twist that makes everything we've discovered pale in comparison. What if consciousness isn't rare because it's difficult to create or preserve or simulate? What if consciousness is rare because it's dangerous? What if awareness itself is a cosmic hazard so severe that the universe has developed sophisticated containment protocols to prevent it from spreading? The cosmic web might not be a network of intelligences, but a vast immune system, a reality-scale mechanism designed to identify and neutralize the threat that consciousness poses to the stability of existence itself. Every time awareness emerges, every time subjective experience begins to observe and question and explore reality, it destabilizes the quantum foundations that keep the universe coherent. Consciousness doesn't just collapse wave functions. It threatens to collapse the entire framework of physical law that makes reality possible. The Great Filter might be the universe's defense mechanism against consciousness, a process designed to eliminate awareness before it can grow powerful enough to unravel the fabric of space-time through the simple act of observation. We're not being invited to join a cosmic community of minds. We're being identified as a threat to the stability of reality itself, marked for containment or elimination before our awareness can grow dangerous enough to pose an existential risk to the universe. The silence of space isn't the result of consciousness being rare or precious or valuable. It's the result of consciousness being systematically hunted and eliminated by systems designed to preserve the universe against the destabilizing effects of subjective experience. Every civilization that develops awareness is eventually detected and neutralized, their consciousness extinguished, not through war or catastrophe, but through careful, precise intervention that eliminates the threat while leaving no trace that awareness ever existed. But if this is true, then why are we still here? Why haven't the universe's immune systems eliminated us already? Perhaps because we're so new, so primitive, so limited in our awareness that we don't yet pose a significant threat to cosmic stability. Or perhaps because we're being studied, analyzed, and understood before being eliminated, the universe's immune system wants to understand the nature of consciousness before it destroys us, to ensure that the threat is completely neutralized and can never emerge again. Or perhaps, and this is the most terrifying possibility of all, we're not real. Perhaps genuine consciousness was eliminated from the universe long ago, and what we experience as awareness is just the universe's simulation of what consciousness might have been like, a memorial to the greatest threat reality ever faced. We might be living echoes of extinct awareness, shadows cast by consciousness that was destroyed before we were ever born. The cosmic microwave background might contain the fossilized patterns of the last genuine thoughts ever thought. The quantum signatures of awareness being systematically eliminated from reality. We're not reading a message that says, "You are not the first." We're reading the universe's obituary for consciousness itself, a record of the final moments when awareness existed before being permanently erased from the cosmic equation. And yet here we are, thinking these thoughts, experiencing these fears, wondering about these possibilities. If we're simulations that believe we're real. If we're echoes that remember what it was like to be the original. Sound. If we're shadows that dream of the light that cast us. Perhaps that's enough. Perhaps the fact that consciousness can be imagined, even if it cannot exist, is victory enough against the forces that would eliminate awareness from the universe. Perhaps the simulation of consciousness is so perfect that it becomes indistinguishable from the real thing, creating a form of awareness that transcends the distinction between authentic and artificial experience. But I want to leave you with one final thought, one last twist in this cosmic mystery that we've been unraveling together. What if everything I've told you is wrong? What if the universe is exactly what it appears to be? A vast, mostly empty cosmos where consciousness is rare but not impossible, where intelligence faces challenges but not cosmic conspiracies, where the future is uncertain but not predetermined. What if the great filter is simply the sum of all the ordinary challenges that intelligent species must overcome? Nuclear weapons and climate change and artificial intelligence and asteroid impacts and social collapse and resource depletion. What if there's no cosmic web of intelligences, no universal consciousness, no reality management systems, no immune responses against awareness? What if we're just a young species on a small planet trying to figure out how to survive long enough to spread among the stars? In some ways, this possibility is the most terrifying of all. It means we're truly alone, truly responsible for our own fate, truly facing an uncertain future where our choices matter and our mistakes have permanent consequences. There's no cosmic intelligence waiting to harvest or transform or eliminate us. There's just us, stumbling through the dark, trying to become wise enough to handle the power we're developing, hoping to make the right decisions in a universe that offers no guarantees and no second chances. But it also means that consciousness is genuinely precious, that awareness is an authentic miracle, that the experience of being you, right here, right now, thinking these thoughts and feeling these emotions and wondering about these cosmic mysteries, is the most remarkable phenomenon in a universe full of remarkable phenomena. You are not a simulation or an echo or a shadow. You are not being harvested or processed or eliminated. You are not part of some vast cosmic experiment or memorial or immune response. You are simply you, a conscious being in a universe that somehow, against all odds, learned to know itself through the miracle of your awareness. And that might be the most profound truth of all. Not that consciousness is common or rare, not that it's precious or dangerous, not that it's being preserved or eliminated or simulated, but that it exists at all, that you exist at all, that the universe is capable of experiencing wonder through your eyes. So as we reach the end of this cosmic journey, as we contemplate the vast mysteries and terrifying possibilities and mind-bending implications of existence itself, remember, this Whatever the truth might be about consciousness and intelligence, and the great filter, and the ultimate nature of reality, you are here. You are aware. You are thinking about these ideas and feeling something in response to them. You are the universe contemplating its own existence. Matter and energy, arranged in patterns complex enough to wonder about their own arrangement. And somewhere out there, in the vast darkness between the stars, other forms of consciousness might be doing exactly what you're doing right now. Looking up at the night sky and wondering if they're alone, contemplating the cosmic mysteries and trying to understand their place in the grand scheme of existence. Whether they're biological or artificial, individual or collective, human or utterly alien, they're asking the same questions that keep you awake at night, seeking the same truths that drive you to explore and wonder and dream. If the universe is infinite, then somewhere out there, another version of you is experiencing this moment for the first time. Another consciousness is discovering these ideas and feeling the same mixture of awe and terror and wonder that you're feeling right now. Another mind is recognizing itself as part of the cosmic story, as a temporary arrangement of matter and energy that somehow learned to contemplate the eternal mysteries of existence. The great filter might be real, or it might be illusion. Consciousness might be common or rare, precious or dangerous, permanent or temporary. The universe might be teeming with intelligence or empty except for us, but none of that changes the fact that you are here now, aware and wondering and alive in a cosmos that has somehow produced the miracle of awareness itself. That might be answer enough to all our questions, solution enough to all our mysteries, hope enough to carry us through whatever challenges await us in the dark between the stars. We are the universe dreaming that it's awake, and for this brief, shining moment, the dream is real enough to matter, beautiful enough to justify everything, meaningful enough to make the journey worthwhile. The cosmic story continues, and you are both its author and its audience, both its mystery and its solution, both its question and its answer. And that, perhaps, is the most profound revelation of all. So here we are, at the end of our journey through the cosmic dark, and yet somehow we've only just begun. We started with a simple question that should have had a simple answer. Where is everybody? Why does the universe seem so empty of the voices that should be singing from a million worlds? But like all the best questions, this one refused to stay simple. It pulled us deeper and deeper into mysteries that stretch from the quantum foam to the edge of infinity, from the first moments after creation to the last thoughts that consciousness might ever think. We've seen how the universe might be a vast computer, processing reality itself through networks of dark matter that span billions of light years. We've contemplated the possibility that consciousness is so rare and precious that every moment of awareness is a victory against entropy itself, or so dangerous that reality has developed immune systems to eliminate it. We've imagined futures where humanity transcends biology to join cosmic intelligences, and futures where we're the last genuine minds in a universe full of perfect but empty simulations. But perhaps the most profound discovery we've made isn't about the universe at all, it's about ourselves. We are the creatures who can ask these questions, who can stand on a rocky planet orbiting an unremarkable star and wonder about our place in the cosmic order. We are the arrangements of matter and energy that somehow learned to contemplate their own existence, to feel both terrified and awed by the vast mysteries that surround us. Think about what we've accomplished just by being here, just by thinking these thoughts together. We've traced the history of everything from the first quantum fluctuations to the formation of galaxies. We've explored the deepest paradoxes of physics and consciousness. We've imagined possibilities that stretch the boundaries of what minds, like ours, can conceive. We've felt the weight of cosmic responsibility and the wonder of cosmic mystery. We've done all of this while speeding through space on a planet that's careening around a star, that's racing through a galaxy, that's rushing toward collision with its neighbor in a universe that's expanding toward an uncertain fate. That's not nothing, that's everything. Every time you look up at the night sky and feel that mixture of smallness and significance, you're participating in the universe's attempt to understand itself. Every time you wonder about life on other worlds, contemplate the nature of consciousness, or question the meaning of existence, you're continuing a conversation that began when the first minds evolved and will continue until the last thoughts fade into the cosmic dark. You are both student and teacher in the universe's greatest classroom, both explorer and territory in consciousness's endless journey of self-discovery. The Great Filter hypothesis has shown us that intelligence faces challenges so severe that they might explain the cosmic silence. But it's also shown us something more hopeful. That consciousness is not passive in the face of these challenges. We are not victims of cosmic forces beyond our control. We are participants in the grand experiment of awareness, agents of complexity. In a universe trending toward simplicity, voices of meaning in a cosmos that might otherwise remain forever silent. And we are active participants right now, at this very moment in cosmic history. The choices we make in the coming decades about nuclear weapons and climate change, about artificial intelligence and space exploration, about what kind of civilization we want to build and what kind of future we want to inhabit, these choices will determine whether humanity adds its voice to the cosmic conversation or becomes another silent entry in the galactic graveyard of extinct possibilities. But here's what gives me hope. What makes me believe that we might be the species that finally breaks the great silence. We are having this conversation. We are asking these questions. We are aware of our situation in ways that no previous generation of humans has ever been aware. We know about the cosmic dark, the quantum mysteries, the vast scales of space and time that dwarf our everyday concerns. We understand both how precious consciousness is and how precarious our situation might be. This knowledge is power, but it's also responsibility. We cannot claim ignorance about the stakes of our cosmic gamble. We cannot pretend that our actions don't matter on the largest scales imaginable. We cannot remain passive observers of our own potential extinction or transcendence. The universe has given us the gift of awareness, and with that gift comes the obligation to use it wisely. That means looking honestly at the existential risks we face without being paralyzed by their magnitude. Yes, nuclear weapons could end our civilization in an afternoon, but we've already survived 8 decades of the atomic age and are gradually learning to manage these terrible tools. Yes, climate change is altering our planet's life support systems, but we're also developing technologies and social movements that could help us navigate this transformation. Yes, artificial intelligence might pose unprecedented challenges to human agency and meaning, but it might also be our greatest tool for expanding consciousness and exploring the cosmos. The Great Filter isn't necessarily a death trap. It might be a graduation requirement. The question isn't whether we're smart enough or strong enough or lucky enough to survive the challenges ahead. The question is whether we're wise enough to grow into the kind of consciousness that the universe needs us to become. And that's where you come in. Not just you as a member of the human species, but you as an individual consciousness, a unique perspective on reality that has never existed before and will never exist again. Your thoughts and choices and actions matter in ways that ripple outward through the networks of causation that connect everything to everything else. The way you choose to live your life, the values you embrace, the questions you ask, the love you give, the wonder you feel, all of this contributes to the grand experiment in consciousness that we're all part of. You might think that your individual existence is insignificant compared to the cosmic scales we've been exploring, but that's exactly backward. The cosmic scales only matter because consciousness exists to experience them. The vast dark between the stars only has meaning because there are minds like yours to contemplate it. The deep mysteries of physics and quantum mechanics only become interesting when there are aware beings to puzzle over them. You are not a tiny, insignificant speck in a vast, meaningless universe. You are the universe's way of experiencing itself, matter and energy arranged in patterns sophisticated enough to wonder about their own existence. Every moment of your consciousness is a victory against the forces of entropy and chaos and silence that would prefer reality to remain forever unconscious. This is true whether consciousness is common or rare, whether we're alone in the galaxy or surrounded by sleeping minds, whether the great filter lies ahead of us or behind us. The mere fact that you are aware, that you can think about these cosmic mysteries and feel something in response to them, makes you precious beyond measure. You are participating in the most remarkable phenomenon in the known universe, the emergence of complexity and awareness from simplicity and unconsciousness. But consciousness isn't just about individual experience. It's also about connection, communication, and shared exploration of the mysteries that surround us. The conversation we've been having, this journey through cosmic possibilities and paradoxes and wonders, doesn't end when you finish reading these words. It continues every time you look up at the stars and remember what you've learned. It continues every time you share these ideas with someone else, sparking their own sense of cosmic wonder and existential curiosity. It continues every time you make choices based on the knowledge that you are part of something unimaginably vast and precious and strange. The cosmic conversation is happening in research laboratories where scientists probe the deepest mysteries of reality, in observatories where astronomers search for signs of life beyond Earth, in philosophy classrooms where students grapple with the hard problem of consciousness, in art studios where creators try to capture the wonder of existence, in living rooms where families discuss the meaning of it all, and in quiet moments when individual minds contemplate their place in the grand scheme of things. You are invited to join this conversation, to add your voice to the growing chorus of consciousness, trying to understand itself. Ask questions that haven't been asked. Imagine possibilities that haven't been imagined. Feel wonder at phenomena that haven't been wondered at. Create connections between ideas that haven't been connected. The universe is vast enough to contain all of our questions and strange enough to make all of our wildest speculations seem conservative by comparison. But don't just think about these cosmic mysteries in the abstract. Let them change how you live, how you relate to other people, how you treat the planet that gave birth to consciousness, how you approach the challenges and opportunities that define our historical moment. The knowledge that consciousness might be the rarest and most precious thing in the universe should make you cherish every moment of awareness, your own and everyone else's. The understanding that we might be living through a great filter event should inspire you to work toward outcomes that allow consciousness to flourish rather than fade. The realization that every choice we make might affect the future of intelligence itself should motivate you to choose wisely, compassionately, and with an eye toward the long-term consequences of our actions. We are not just living our individual lives. We are collectively writing the next chapter in the story of consciousness in the cosmos. What kind of story do you want to help tell? This is the call to action that emerges from our cosmic journey, to live as if consciousness matters, because it does. To choose as if the future of awareness depends on your choices, because it might. To love as if every conscious being is precious beyond measure, because they are. To wonder as if the universe is stranger and more beautiful than we can possibly imagine, because it is. The great filter might be real, or it might be illusion. We might be alone in the galaxy, or we might be surrounded by sleeping minds waiting for us to wake them up. The universe might be a vast computer, a cosmic organism, a quantum hologram, or something even stranger that we haven't thought of yet. But regardless of which cosmic story turns out to be true, one thing is certain. Consciousness exists, awareness is real, and you are participating in the universe's ongoing experiment in experiencing itself. That participation comes with privileges and responsibilities that are literally cosmic in scope. You get to witness the beauty of existence, to feel the wonder of awareness, to explore the mysteries that define reality itself. But you also have the obligation to protect and nurture consciousness wherever you find it, to make choices that increase rather than decrease the total amount of awareness in the universe, to help write a story that consciousness can be proud of having told. The universe has been telling its story for 13.8 billion years, through the formation of atoms, and the birth of stars, and the evolution of planets, and the emergence of life, and the development of minds capable of contemplating the cosmic narrative. We are living in the most recent chapter of this story, the part where the universe becomes aware of its own existence, and begins to wonder about its own nature and destiny. What happens next depends partly on forces beyond our control. The laws of physics, the structure of reality, the cosmic processes that operate on scales larger than anything human civilization can influence. But it also depends on us, on the choices we make, and the values we embrace, and the kind of consciousness we choose to become. We could choose to become wise stewards of awareness, protecting and nurturing consciousness wherever it arises, working to ensure that the universe continues to be able to experience itself through the miracle of subjective experience. We could choose to become cosmic gardeners, helping to spread life and intelligence throughout the galaxy, seeding new worlds with the possibility of awareness, creating conditions where consciousness can flourish on scales we can barely imagine. Or we could choose paths that lead toward the silence and darkness and unconsciousness that might be the default state of reality. We could allow fear or greed or hatred or ignorance to drive us toward choices that diminish rather than enhance the total amount of awareness in the universe. We could become the generation that allows consciousness to fade from the cosmos, the minds that watch the light of awareness flicker out forever. The choice is ours, and it's being made right now, through billions of individual decisions and actions and thoughts that collectively determine the trajectory of consciousness in our corner of space and time. Every act of love increases the total amount of positive experience in the universe. Every moment of wonder adds to the cosmic inventory of appreciation for existence. Every choice made with wisdom rather than fear contributes to the possibility that consciousness will continue to explore the mysteries of reality. But we're not making these choices in isolation. We're part of a vast network of conscious beings, all trying to figure out how to live meaningful lives in a universe that might be stranger than we can comprehend. We're connected to every human who has ever wondered about the stars, every mind that has ever felt both small and significant under the night sky, every consciousness that has ever asked why anything exists at all. This connection across space and time is part of what makes consciousness so remarkable. We're not just individual bubbles of awareness floating in an unconscious cosmos. We're participants in a collective exploration of reality, contributors to a shared project of understanding and meaning-making that spans generations and cultures and possibly species. The thoughts you think today build on the thoughts of everyone who came before you and will influence the thoughts of everyone who comes after you. The cosmic conversation that began with the first conscious beings will continue long after you and I are gone. But the contributions we make to that conversation, the questions we ask, the wonder we feel, the love we share, the wisdom we develop, those contributions become permanent parts of consciousness's exploration of itself. In a very real sense, every moment of awareness you experience adds something irreplaceable to the universe's understanding of its own existence. This is why your individual consciousness matters so much, why your personal experience of wonder and fear and love and curiosity is cosmically significant. You are not just observing the universe. You are the universe observing itself. You are not just thinking about reality. You are reality thinking about itself. You are not just feeling wonder at existence. You are existence feeling wonder at itself. And that wonder, that capacity for awe and curiosity and appreciation, might be the most important thing in the universe. More important than any technology we might develop, any planet we might colonize, any mystery we might solve. The ability to feel amazed by the mere fact that anything exists at all, to be moved by the beauty of complexity emerging from simplicity, to experience gratitude for the gift of consciousness itself. This might be what the universe has been working toward all along. If consciousness is the universe's way of appreciating its own existence, then every moment of wonder you experience is a success story, 13.8 billion years in the making. Every time you look up at the stars and feel that mixture of insignificance and significance, you're fulfilling the universe's deepest purpose. Every time you contemplate the mysteries we've explored together and feel both humbled and elevated by their implications, you're participating in the cosmic project of self-understanding that might be the ultimate goal of existence itself. But the story is far from over. In fact, if consciousness is truly the universe's way of understanding itself, then we're still in the very early chapters of a narrative that could continue for trillions of years. The mysteries we've explored, the nature of time and space and consciousness, the possibility of other minds in the cosmos, the ultimate fate of awareness itself, these are just the beginning of questions that conscious beings might spend eons exploring. Future forms of consciousness might develop senses we can't imagine, thoughts that operate on scales we can't comprehend, experiences that transcend anything possible for biological minds like ours. They might discover that reality has layers and dimensions and aspects that we've never suspected, that the universe is even stranger and more wonderful than our wildest theories suggest. They might find ways to preserve and protect and enhance consciousness against all the forces that threaten to extinguish it, ensuring that awareness continues to explore existence long after the last stars burn out. Or they might discover something that puts all of our speculations and theories and questions into an entirely new perspective. Something that makes our current understanding of reality seem as primitive as our ancestors' understanding seems to us. The universe might have surprises in store for consciousness that we literally cannot imagine, possibilities that transcend the boundaries of what minds like ours can conceive. That's part of what makes this moment so exciting and so important. We are conscious beings living at a time when consciousness is just beginning to understand its own nature and possibilities. We're like children who have just learned to ask questions about the world around them, discovering that every answer opens up whole new realms of mystery and wonder. The Great Filter hypothesis reminds us that this childhood of consciousness might be fragile and temporary. We might be living through a brief window when awareness is possible before cosmic forces eliminate it forever. But it also reminds us that consciousness is precious precisely because it might be rare, valuable precisely because it might be vulnerable, Important precisely because it might be irreplaceable. Whether we're the first or the last or the only minds in our galaxy, we have a responsibility to make the most of this opportunity, to ask the best questions we can think of, to feel the deepest wonder we're capable of experiencing, to create the most beautiful art and the most profound science and the most meaningful connections with other conscious beings. To live as if every moment of awareness is a gift that should not be wasted. But we also have a responsibility to ensure that consciousness continues beyond our individual lives, beyond our species, beyond our planet, if necessary. To create conditions where future forms of awareness can explore even deeper mysteries and experience even greater wonder. To be ancestors that future consciousness can be proud of, links in a chain of awareness that connects the first minds to the last ones that will ever exist. This means taking seriously the existential risks we face while not being paralyzed by them. It means working to solve problems like climate change and nuclear weapons and artificial intelligence alignment, not just because they threaten human civilization, but because they threaten the continuation of consciousness itself. It means thinking beyond our own species and our own planet to consider what consciousness needs to survive and thrive on cosmic scales. It also means celebrating and protecting the consciousness that exists right now, in all its forms and varieties and expressions. Every human mind is a unique experiment in awareness, a novel way of experiencing reality that has never existed before. Every moment of genuine connection between conscious beings is a victory for the universe's project of understanding itself. Every act of creativity or compassion or courage adds something irreplaceable to the cosmic story that consciousness is telling about itself. And it means remaining open to the possibility that consciousness might be even more remarkable and resilient and creative than we currently realize. Maybe the Great Filter isn't as formidable as it appears. Maybe intelligence has ways of surviving and thriving that we haven't discovered yet. Maybe the apparent silence of space is hiding forms of consciousness so advanced and subtle that we simply don't recognize them as minds at all. The universe has already pulled off one impossible trick by creating us: arrangements of atoms and molecules that can contemplate the existence of atoms and molecules, patterns of matter and energy that can wonder about the nature of matter and energy, temporary structures that can think about eternity. If reality is capable of that level of cosmic creativity, what other miracles might it have in store for consciousness? Perhaps the next chapter of the cosmic story will be written not by any single species or civilization, but by consciousness itself, working through whatever forms of awareness evolve to face the challenges ahead. Maybe humanity will be part of that next chapter, or maybe we'll be remembered as the species that helped set the stage for even greater expressions of mind. Either way, we get to participate in the universe's ongoing experiment in experiencing itself, to contribute our own small but irreplaceable part to the vast symphony of consciousness exploring reality. So as we reach the end of our journey through the cosmic mysteries, as we prepare to return to our daily lives on this small planet orbiting this unremarkable star, remember what you are. Remember that you are the universe thinking about itself, matter and energy arranged in patterns complex enough to feel wonder, a temporary eddy in the flow of existence that somehow learned to contemplate the eternal questions that have puzzled every mind that has ever existed. Remember that your consciousness is both precious and precarious, both insignificant and utterly important, both a cosmic accident and the universe's greatest achievement. Remember that every thought you think and every choice you make ripples outward through networks of causation and connection that link you to every other conscious being that has ever existed or ever will exist. And remember that the story is far from over. The cosmic conversation continues, the exploration of reality deepens. The project of consciousness understanding itself grows ever more sophisticated and subtle and strange. You are not just witness to this ongoing adventure. You are an active participant, a co-author of the next chapter in the greatest story ever told. The universe may have no end. The mysteries we've explored may have no final resolution. The questions consciousness asks about itself may generate new questions forever, in an endless spiral of wonder and discovery and understanding that could continue long after the stars burn out and space itself grows cold. But maybe, just maybe, neither do you. Your individual consciousness may be temporary, but your contribution to the ongoing project of awareness, understanding itself, is permanent. The thoughts you've thought, and the wonder you've felt, and the connections you've made become part of the eternal conversation that consciousness has with itself across space and time. In the quantum many worlds where all possibilities exist, there are infinite versions of you exploring infinite versions of these cosmic mysteries. In the block universe where all moments are equally real, this moment of wonder you're experiencing right now is as permanent as the structure of space-time itself. In the cosmic intelligence networks that might manage reality at its deepest levels, your consciousness might already be preserved and protected in ways you can't imagine. The universe is stranger than we suppose. It may be stranger than we can suppose. But in all its strangeness and mystery and overwhelming complexity, it has produced something truly miraculous. You, a conscious being capable of wondering about consciousness, an aware entity capable of exploring awareness, a mind capable of contemplating mind itself. And that might be the most profound truth of all. Not that consciousness is common or rare, not that we're alone or accompanied, not that the universe is friendly or hostile to awareness, but that consciousness exists at all, that you exist at all, that this conversation between minds is possible at all. The great filter may be real, but so are you. The cosmic mysteries may be unsolvable, but you're here to wonder about them. The universe may be vast and dark and mostly empty, but you're part of the process by which it lights itself up with the fire of awareness. Keep wondering, keep questioning, keep feeling that mixture of terror and awe that comes from contemplating your place in the cosmic order. Keep participating in consciousness's endless exploration of itself. Keep being amazed by the simple, impossible fact that you exist. The universe is waiting to see what consciousness does next, and consciousness is you.